polygons, two specialized polyline tools. You can find both of them on this flyout. We'll begin with the rectangle. As the icon suggests, rectangles are... This video is about rectangles and polygons, two specialized polyline tools. You can find both of them on this flyout. We'll begin with the rectangle. As the icon suggests, rectangles are made by clicking two opposite corner points. I'll do that here. Very straightforward. I'll select the rectangle, and you'll see that it's actually a polyline. That means that we have access to its grips, just as if we had drawn this using the p-line command. We can then reposition these vertices if we want, or convert straight lines into arcs, and so on. So I'll press Escape to deselect. Let's try rectangle again, and this time we'll use a different option. Let's try fillet, this option here. Some people say fillet, I say fillet. The fillet is a radiused transition between each edge. So we're going to specify that distance here. I'll type in 1, enter, and then I'll go ahead and proceed to draw the rectangle. And you'll see what's happening here. We're creating a rounded rectangle. What used to be a corner is now this filleted radiused transition. This option is sticky. That means it persists. So if I create another rectangle, which I'll do by pressing the space bar, it's going to have that same fillet radius built in. If I want to set that back to get rid of it, I have to set the fillet radius to 0. So I'll do that next. Press the space bar and the down arrow, choose fillet, type 0, enter. And now just to show you that it's cleared out, I'll draw another rectangle. Let's try the chamfer option next. It requires the input of two different distances. Let's try 1 and 1 again so that they're equidistant. Now draw the rectangle. So what we have here is a beveled edge. The two distances are the vertical distance and the horizontal distance. I set them equal so that we would get a 45-degree bevel. This is also sticky, so if I draw another rectangle, it's going to have that setting on. So let's just go back and reset that. I'll go to chamfer and set the two distances to 0 and 0. Just like the p-line command, you can create rectangles that have width. I'll use the width option, and I'll set the width to 1. This creates a fat rectangle. And again, the value is sticky. I need to go back and reset width to 0 if I want to clear that out. Let's try drawing some polygons next. Polygons have equal length sides, so you can create things like triangles, squares, pentagons, hexagons, and so on. Let's try drawing a square. The number of sides is 4. I'll press enter to accept that as the default. Now it says specify center of polygon. I'll just click a point. And then you have an option whether you want that to be inscribed within a circle or circumscribed about the circle. That means outside of it. I'll take the default inscribed in circle by pressing enter. Now you can see what's happening. I'm drawing this square, and there's an imaginary circle that is surrounding it. And so we're specifying the radius of that circle right now. You can use ortho by pressing F8 to make sure that this is locked into a vertical orientation. If you go over here, you can do that horizontally, but the result is the same. You're creating a sort of diamond shape. Let's try that again with 4 sides, but this time I'll press the down arrow and use this single option called edge. This allows us to specify the edge length, and that's done by clicking 2 points. I'll click the first endpoint of the edge there, and the second one here. Of course, I could have used a number there to specify that distance if I wanted to. But this way you can create squares that are oriented orthogonally. Where the polygon command gets really interesting is where you start to create polygons with more sides than 4. Let's try creating an octagon. I'll set 8 sides. Click a point. I'll inscribe it within a circle. You can see the result. So you can quickly create any type of polygon with this command. I'll create a pentagon and a hexagon, just like that. You can always use the edge option. So if I wanted to make a 7-sided septagon, I could then use the edge option and click 2 points to specify the edge length right there. I need to zoom extents to see that. So this is my favorite one because you can't construct this manually with a compass and a ruler. However, AutoCAD can do it very precisely. So there you have it, 2 specialized polyline commands, rectangle and polygon. In this video, I'll discuss points and donuts. Both create dots on the screen. Points are single pixels, and donuts can have a larger size. Type PO for point, and this command has no options. You simply specify a point, and you have a single pixel on the screen there. I'll do that again. I'll press Enter to repeat the command and simply click a point. These can be useful as placeholders. They specify these positions. I could later on perhaps draw an arc between them. To do so, I'll use the arc tool in the default 3-point mode, and I'd like to snap to that point. I'll hold down Shift and right-click to access the Object Snap menu. And if you want to snap to a point object, you have to use Node Snap. That's shown there in green. I'll click right there, and the first point of the arc snaps precisely to that point. I'll press F8 to turn off ortho. Click the second point of the arc here, and the third point of the arc I want to click right on that point. So I'm going to hold down Shift and right click, choose Node, and then click on the point. So that arc bridges perfectly between those 2 point objects. You can change the way the points are displayed using a command called DDP type. DDP type. It's a little known command, and the DD refers to dialog box, going way back in AutoCAD's history. Here we have different ways we can display points. If you choose this second method, the points will disappear entirely. You can choose any of these shapes and click OK, and the points will have a different appearance so that they're easier to see on screen. This can be useful when you're looking for these placeholder objects and they're just single pixels. They might be on top of another object and therefore impossible to see otherwise. Now, points are located here on the Draw Slide Out, right here on this icon. Now, donuts are located here, and as the icon suggests, it allows you to create a hollow ring or a filled ring. The donut with Now, donuts are located here, and as the icon suggests, it allows you to create a hollow ring or a filled ring. The donut with the donut hole, if you will. The donut command actually creates 2 arcs joined together that are part of a polyline, and they're filled, so it creates a nice dot or a ring. And you create that by specifying 2 diameters. The inside diameter, usually reserved for the void, and the outside diameter. So let's try the inside diameter is 1, and the outside diameter is 3. I'll click right here to create a donut, and then I'll press Enter to end the command. I'll zoom in there, and you can see that it, sure enough, has a hole in the middle. If I position the cursor over the object, this object is revealed as a polyline. So this is just a specialized way of creating such a shape. Donuts are often used as the endpoint of a leader object, like a dot. And to do that, you would create a point with a 0 radius for the inside. So let's just go ahead and make another donut, and I'll type the inside diameter is 0, and let's say the outside is 1. Then I can click and create these dots. Now these dots have a certain size, so if I zoom in, they get bigger, unlike the point object, which always remains at its small size. So that's the difference between them. Don't use donuts as placeholders in space, but use them as the endpoint of a leader or something like that, where you're calling out a specific feature, or the geometry that you're modeling is actually a circle that needs to be filled. This video is all about selection. Before you can modify objects, you need to select them. And it doesn't really matter how you want to modify them. You might want to move them, copy, rotate, scale, what have you. But all of those commands start with a select objects prompt. Open the architectural sample file, and let's go ahead and click Move up here. It says Select Objects. The most obvious way to select something is just to click on it. It's called picking. This works well, but it's very inefficient. Let's say I wanted to select all of the objects comprising this stair. I don't want to sit here and click on each and every line. Fortunately, there's a better way to do that. You can create a window around the stair. Click right about here, and then move the cursor down to the right. If I click right here, watch what happens. All that gets selected. I'm just going to press Escape to cancel the command. Let's try that again. Go back to Move, and this time, instead of starting up here, start in the lower right corner of your intended selection area and go up to the left. The window is green. This means that it's a crossing window. It's going to select anything that this window crosses. Now this is different. I got a lot more selected because it got, say, these handrails here that go way over this far. Let's try that again. Move. If I make a window going this way, only the objects that are completely contained in that window get selected. If the window goes over this way, anything that the window crosses gets selected. So this is really an important distinction. It's the difference between what we call a regular selection window and a crossing window. Another way you can select is using a fence. I'll click Move, and at the Select Objects prompt, I'll type F for fence and enter. Notice that it's not an option. You have to know this. It doesn't prompt you for it on the command line. F enter indicates that I want to select using a fence. The fence works like the crossing window in that anything that it crosses gets selected. But this allows you to select things that are not necessarily in a rectangular region. Another way you can select is using the lasso, and this works at any Select Objects prompt. Simply start dragging. You can draw out this lasso. It selects objects that are completely inside the lassoed area. It doesn't matter with the lasso which direction you drag in. I can drag in this direction or the other one, and it's only going to select objects that are completely contained in that lassoed area. Let's go back to the Select Objects prompt just by clicking any of these modification commands. Now I'm going to select a few objects manually. And let's say that I accidentally selected something like that I didn't want to select. I can remove it from the selection set by holding down the Shift key. Now if I pick on this object, it will remove it from the selection set. I can then let go of Shift and keep selecting. If, on the other hand, you've built up a large selection set and you want to, just focus in on the things you want to deselect, you can type R for remove and press Enter. That actually changes the prompt. Notice it says remove objects now. So without holding Shift, I can use any selection method to remove objects from the selection set. Now let's say I want to go back and keep selecting objects again. I can type A for add, Enter, and the prompt goes back to select objects. And here I can go ahead and add more to the selection set. I'll press Escape again. So now I'd like to draw just 2 lines over here, doesn't matter where. And I'd like to show you a couple of very useful selection modes. The first one is called last. Last selects the last object that you created, but it's only good for a single object. So let's say I want to move the last thing I just created. I'll type L, Enter for last. And it got that line right there. I can then proceed to move it. Let's try moving both objects. I'll select them both just by picking them, and I'll go ahead and move them. This time, let's say I realized, I didn't want to move those, I actually wanted to copy them. I could undo and redo this, but another method is just to use the previous selection set. So I'll click Copy and type P, Enter for previous. That's going to select whatever I was just working on, and it can have more than one object in the selection set. So I can then copy those objects. Now let's say I want to do that again. Let's try copying the previous selection set. It doesn't select the very last objects that I created. It selects those same objects that I was working on, those first 2 lines. So previous is sort of a great power tip that I use all the time. It saves time in having to reselect what you're working on. There's also all. You can select all the objects in the drawing by just typing all. So I'll go to Move, and then at the Select Objects prompt, I'll just type in all, and it gets everything in the drawing, and then you can go ahead and modify that. Say I want to move it. However, all does not select objects that are frozen, and that's another story. You'll learn about that with layers. There are a few other selection methods that are quite useful. Let me just erase these lines that we've been experimenting with here. Now, let's say I want to select all these stairs, and it's a bit tricky because the handrails go through them. The stair has a lot of horizontal tread lines and some vertical lines that complete the stair. So it's just a bit of a selection nightmare. In this case, I might select just one object by clicking on it without even using a command. This turns on the grips. I can then right-click to get a special shortcut menu, and I'll choose Select Similar. This is going to get all of the lines in the stair. And what this does is it actually analyzes the whole drawing, and it checks to see if the objects are on the same layer and if they're of the same type. So in this case, it's looking for lines that are on this A floor stairs layer. I'll just press Escape. Now I'm going to zoom in here on the handrail, or on this guardrail here, and I'll click on this little circle. Right-click and say Select Similar. It's going to select circles that are on that layer, on A floor handrail, but it's not going to select lines. So Select Similar is specific to the object type and the layer. Let's take a look at yet a few more selection methods. And I promise we're almost done here, but I think these will suit you well in the long run. Selection is something that you do all the time, and it's important to find the best tool for the job. So I'm going to type in PROP for properties. This opens up this palette, and there are a few selection tools in the corner here. Quick Select is very powerful. It allows you to select objects by type and other properties. So, for example, I could apply this selection filter to the entire drawing or to a subset of it. I could select, say, this whole area to work on. Enter. So that's going to apply this filter to the current selection. And then I could say I want to select all of the lines that are in that selection. And I want all of the lines that are on a specific layer. Or I could say all of the lines that are a specific color. And click OK. And it's going to select that very specific set of criteria that you set up. This here is called Pick Add. And if you turn that on, it changes the way that selections work. Normally, you can keep adding to a selection, but when Pick Add is on, only one thing can be selected at a time. So I can go ahead and click on different things, and you'll see that only one object is selected at a time. When this mode is off, I can continue adding to the selection set like that. So there you have it. You've seen many different ways to select objects. In this video, I'll discuss the move and copy commands. I'll also cover the copy command's array option, which lets you copy multiple objects all at once. Open the architectural sample file and zoom into the living room over here on the right. Let's start by moving this lounge chair around to gain some practice with the move command. Click Move on the Modify panel, and you're at a Select Objects prompt. Pick the lounge chair, and you're still in the Select Objects prompt. So we need to exit from this selection mode. You can do that by pressing the space bar or the Enter key. Now it says Specify Base Point. Basically, with the Move command, you'll be moving from point A to point B. The base point you can think of as point A. And in this case, it doesn't really matter where the base point is on the screen. We just need to click someplace. I'll click right here. Now we move on to the next prompt. It says Specify Second Point. This would be our point B. I can move the cursor and then click to specify point B. So it's really very straightforward. Let's try that again. M, enter. Click, enter. Click, click. So I've moved the lounge chair a second time. In many situations, you'll want to move an object a measured distance. Let's say I want to move this lounge chair up 4 feet in the vertical direction. I'll type M, enter, click the chair. This time I'm going to right click, and it works just the same as the space bar or the Enter key. I'll specify some arbitrary base point by clicking somewhere on the screen. And I want to move this up vertically, so I'm going to turn on ortho. That's this mode right here. I'll move the cursor up relative to the point A or base point that I selected. And the tooltip is telling me how far I'm moving it. I don't recommend that you carefully move this until it says 4 feet, because you'll probably miss it by a little bit. If you want to move it exactly 4 feet, all you have to do is type 4 feet. The feet symbol is the apostrophe, which is right next to the Enter key on most keyboards. So I typed 4 foot, enter, and I moved the chair up exactly 4 feet vertically. In other situations, you might want to move objects relative to others, and you can use Object Snap to make sure that you're precise. So let's move this chair. I'll click it, right click to exit from the Select Objects mode. And this time, the base point matters. It matters exactly where that is. So I want to pick this midpoint here. So to do that, I'm going to hold down the Shift key and right click. That allows me to have access to this handy Object Snap menu. I'll choose midpoint. And then if I move the cursor close here, you'll see this green triangle symbol appear. This would be good for any midpoint of any object. In this case, I want the base point to be right here, so I'm going to click while that green symbol is shown. I'll turn off ortho by pressing the F8 key. And now it says specify second point. So this is really the point B. It's where I want to move the chair to. I'd like to move it right here at the midpoint of this coffee table. I'll hold down the Shift key, right click, and choose midpoint again. Now I'll move the cursor so the midpoint symbol shows up, and I don't have to click it right on there. I could click it over here. As long as that green symbol is illuminated, it will snap it directly to that midpoint. So I'm going to click right now, and that completes the move command. Now let's move this chair up a couple of feet vertically. I'll select it, right click, click an arbitrary base point in this case, turn on ortho by pressing F8, move the chair up. Let's move it up 2'3". I'll type 2'3", enter. So I've restored the lounge chair more or less to its original position. Now copy works very much like the move command. The only difference really is that it leaves the original object behind. So let's try copy. I'll select this lounge chair and press enter. At this point, it looks identical to the move command. It says specify base point. I'll click some arbitrary point. I'll move the cursor to the right and click again to specify the second point. Then press enter to end the command. So I've essentially moved this over and left the original behind. That's essentially what copy does. Let's try that again. Copy this chair. So I've clicked it. I'll right click to exit from the select objects mode. Now I'll specify some arbitrary base point. I'll move over to the right and click. That would be the second point. Notice, however, that the copy command keeps going. That allows me to make multiple copies. I could then click another second point, and so on. I could turn off ortho by pressing F8 and make copies all over the place. I'll press enter. Now let's say I want to make a series of chairs that are spaced equally. We can use the copy command's array option to do this. Click copy, select one of the lounge chairs and right click. Specify some arbitrary base point. Turn on ortho and press F8. Now I'd like to make an array, and you'll notice down on the command line that you have that single option, array. Click array or type A enter to use that option. Now it says enter number of items to array. Type 3 enter. And look at what's happening. We have a total of 3, including the original. And this can be a source of some confusion for people, because if you're thinking, oh, I want to have 2 more chairs, you have to actually add 1 to that because you have to count the original. So in this case, we want 2 more chairs, so we have an array of 3. So depending on where I put the cursor, it will add more space equally between the chairs. So I could click here and press enter to complete the command. Alternatively, I could use the fit option within array. Let's try that next. I'll do copy, and I'll select all 3 of these chairs by making a crossing window. And then right click to exit out of select objects mode. Specify a base point. Click array. And let's say we want 4 items in this array. 4 enter. And now I'll click fit. So fit is going to give me the overall distance that I want to fit these chairs into. So I want to create this theater seating. So let's say we want to fit it in a 12-foot area. So I'll type 12 feet or foot symbol, enter. And then the copy command keeps going, so you have to hit enter again to end the command. So I recommend that you practice moving and copying objects for a while until you become comfortable with the mechanics. In the next video, you'll learn about rotating and scaling objects. In this video, I'll discuss the rotate and scale commands. Open the architectural sample file and zoom in here into this room by the fireplace. Let's begin by rotating this chair. Click the Rotate tool here on the Modify panel. You have a Select Objects prompt. Select the chair and press Enter to exit out of Select Objects mode. Now the command prompt says, specify a base point. Click a point more or less in the middle of the chair. Now you can see what's happening. As I move the cursor, the chair is rotating about the base point. I'll click a point down here to set the rotation angle graphically, and the command is done. Let's pan down here into this living room space. This time, I'd like to rotate the chair here using a set number of degrees. Click Rotate, select the chair, press Enter, specify the base point more or less here in the middle of the chair, and we'll type in 30 for 30 degrees and press Enter. So it's just that simple. In some cases, you might want to rotate objects relative to other objects. So for example, down here, I notice that there's a slab line right here. This represents a floor transition. When you come in through the entry, you'll step down one step into the living room. I'd like to rotate this chair so that it lines up parallel to this step. To do that, I will actually move the chair down here, rotate it, and then move it back. I'll move this chair, Enter, from a base point, which is maybe right here at the midpoint of the backrest. So to get that, I'm going to have to hold down the Shift key and right-click to open up the Object Snap menu. Then I'll select Midpoint and click right here. So I've picked up the chair from a very precise point on it. Now I'm going to snap that chair to the midpoint of this slab line. So again, I need to hold down Shift and right-click to access this menu. I'll choose Midpoint and then click right here, and that completes the Move command. So I've done this because I now have an intersection point, the intersection of this line and the backrest of the chair, that will act as the base point of a rotation. So let's go ahead and rotate this chair, Enter, from the intersection point. So I'm going to hold down Shift, right-click, and choose Intersection, and click right here. So that's the base point of the rotation. And the rotation angle is something I don't know numerically, but I'm going to get AutoCAD to figure that out for me graphically, simply by snapping to this point down here. So again, hold down Shift, right-click, choose End Point, and snap here to the end point of that line. Now the chair is rotated perfectly aligned with this step. I can then move it up into the room like so. Like the rotate command, the scale command also uses a base point which is significant. Let's say we want to scale this coffee table up by a factor of 150%. Let's use the scale tool, which is located right here. Select the table, press Enter, and specify the base point. I'll click a point arbitrarily, sort of down here. And as I move the cursor, you can see what's happening. The table is scaling up or down, depending on how I move the cursor, relative to that base point. So if I wanted to scale it graphically, I can just carefully move the cursor a little bit and click a point. And that will set a scale factor graphically. But that's not really what I want. Let's undo and try this again using a scale factor as a number. So let's scale that again. Scale this object, enter, and this time I'll scale it more or less from the middle of the table. And you can see what's happening there. It's getting bigger or smaller relative to that base point. So I'd like to make it 150% larger, and so the scale factor would be 1.5. Scale factors between 0 and 1 make the object smaller. Scale factors above 1 increase the size of the objects. So here, 1.5 is equal to 150%. I'll type enter, and the table is that much bigger. Now let's say I wanted this table to be larger such that it matches the width of the sofa. To do that, I'm going to move the table down so that it lines up with the sofa. So I'm going to snap to the end point of the table and connect that with the end point of the sofa right here. Now I'm going to scale this up graphically, and I'll show you how that's done. So we're going to scale this table, enter, and the base point is going to be the end point right here. And then I'm going to use the reference option right here. Click reference. The reference length is something I don't know, but I'm going to get AutoCAD to figure that out for me. I'm going to start from the base point, and there's a shortcut for that. Simply type the @ symbol and press enter. That's going to tell AutoCAD that I want to use the same point that I used before. Now the second point is going to be right here at the end of the table. For that, I'm going to have to snap to it. So I'll hold down Shift and right click and choose endpoint right here. Now you can see what's happening. I have the ability to scale this table up from the base point. And because I set that reference length as the full width of the table, I have really precise control over how that's going to be scaled now. It says specify new length. I'd like to snap that right here. So I'm going to hold down Shift, right click, and choose endpoint. And I'll snap that right there. So now the table is perfectly scaled so that it matches the width of the sofa. And I got AutoCAD to figure out the scale factor for me by choosing the reference length and then the new length. Now I can move the table over into the space, and I'll use ortho by pressing F8 so I can slide that horizontally. And now it looks like I need a little bit more room, so I will move this up and perhaps over a bit as well. And I will move this down and over. I'm able to do that quickly because I'm pressing the spacebar to repeat the move command. You can just press spacebar, move this from point A to point B, press the spacebar to repeat move that from point A to point B. So now you've seen how rotate and scale work, and I highly recommend that you spend some time practicing moving the furniture around in this sample file until you become comfortable with the mechanics of these tools. In the next video, you'll learn about the Array tool. In this video, I'll discuss the Array command and its variations. Open the Array sample file to follow along. There are 3 different Array tools here on this flyout menu. Let's start with Rectangular Array. Zoom in to this desk. You have a Select Objects prompt. Select the chair and press Enter. You might need to zoom out to see what's happened. A default array has been generated. Notice that there's a green line around this whole tab. This is a temporary tab. It only exists while you're creating the array. We can set a number of columns and a number of rows. In this case, I just want to have 3 chairs along the edge of the desk. So I need to have 3 columns. Highlight the value here and change it to 3. Press the Tab key to have it take effect. Sometimes it takes a couple of seconds before it updates. The number of rows should be 1. So type 1 and press Tab. You can set the distance between the columns here. So right now it's at 3 foot and 1/2 inch. I'll change that to 2 foot 6 by typing 2'6, press Tab to have that take effect. That's a bit tight. I'd like it to be more or less centered on that edge of the table. I could keep entering values here, or I could enter a total distance. Let's try that. 5 foot 6, Tab. Now that's a bit too much. There's a little less space here as compared to the space over here. Now we could keep playing this game with numbers, or we could do it graphically. I prefer the graphic method because we can just click this grip and move these objects over until it looks just about right, and then click again. This last grip over here sets the number of columns. I can go like this and add more chairs, all with the same spacing. Now, it's very important up here that you choose whether you want this array to be associative or not. If it's not associative, when you close the array, you'll just have 3 independent chair objects. You won't have the ability to come back in the future and edit the array as an array. So I recommend that you do select associative because it gives you more options. I'll click Close Array, and it's done. Now position the cursor over one of these chairs and you'll see that it's all one thing. It's an array. If I click on that, I can then go back here and edit these values. Close Array. Now let's say that I want to have a room of these training desks, so we can make an array of the array. Go up here and choose Rectangular Array again, and this time select the array and the table. I'll make an enclosing window to select all of those objects, and then press Enter to exit out of Select Objects mode. Here we have another default array. Now I don't want this to go up, I want it to go down. And so these are the rows. To do this, I will highlight this value and use the arrow keys to move the cursor to the beginning of this area here and type minus. So we have a negative value between the rows. Then press the Tab key. That flips the array down. I'll use this grip to change the number of columns and rows. So we have a 2 by 2 array. And I can use this grip to increase the number of rows, or this grip to increase the number of columns. This grip is probably the most useful because it allows you to graphically set the distance between the desks. Of course, you can do that with numbers right here, if you prefer. I'll leave this as an associative array and then close it. If I want to go back in, I can just click on any part of that array and make some changes. However, I no longer have access to the chair array within this array, this nested chair array. If I wanted to change that, I could, but I'd have to explode this overarching array. I can click this Explode button, select the array object and press Enter. That blows away that data structure, and now I have individual objects here. So here I have access to this array, and I can change, say, the number of columns to 1 and close that. So I could have sort of a one-off training desk with just one chair at it. So there are also 2 different kinds of arrays beyond the rectangular array that you can create. You can make a polar array that goes around a circle and an array that goes along a path. Let's try those. Go to Polar Array, select the chair, and press Enter. It asks you to specify the center point of the array. And for this, I need to use Object Snap so I can snap to the center of the circle. Hold down Shift and right-click and choose Center. and then click at the center of the circle. The default polar array appears. You can set its parameters up here. Let's say I want 8 chairs. I'll type 8 tab. I'll close the array. And it is associative, so I can click on it in the future and I can make changes to it if I want. Let's close that. Now over here, let's make a path array. Open up the flyout, choose path array, select the chair, right-click or enter. Now it says select path curve. That will be this spline. Now here we have a choice about whether we want to align the items to the path or not. I'll turn that off, and everything retains its original orientation. You can set the distance between the items here. Let's say we want 3 feet between each chair. 3 foot, press tab. There's a little bit more spacing there. I want to make sure that this says associative, so I retain the functionality of the array. If this is off and I close it, then I just have individual chairs that are not connected to each other in any way. But while it's associative, I can close the array and then come back later at some future date and make a change to it. Let's say I want to specify the number of items. I'll click here and say I want to have 7 tab. Close the array. Another nice feature is because this is associated with the spline path, I can select the spline and alter its shape using the grips. And when I do that, all of the objects go along for the ride and they stay connected to that path. I can then also go back and change this and click here on item count to have AutoCAD automatically calculate the number it's needed to maintain this distance between. And maybe I'll also choose to align the objects. That doesn't look so great. Let's go back and specify maybe 8 items and then close the array. So there you have it, all the different ways you can array objects in AutoCAD. In the next video, you'll learn about the offset and mirror commands. Offset and mirror both create new objects from existing ones. You'll use both offset and mirror in this video. To begin, open the room sample file. Click the Offset tool here in the Modify panel. Unlike most of the other modification tools, this one does not begin with a Select Objects prompt. Instead, it says Specify Offset Distance. We can type in a value, or click 2 points to have AutoCAD measure something for us. This first time around, let's just click 2 arbitrary points that aren't too far apart to specify some offset distance. Now the command prompt says, Select Object to Offset. Click on this line, and immediately you go to the next step. It says Specify Point on Side to Offset. Because the cursor is on the left of this line, it is giving me a preview image of the new object. If I move the cursor over here on the right side, I get a different preview. So if I click here, that object will be created. I could click another object, say this line, and then either click above or below it to create yet another new object. I could select this object and offset it to the left, and keep doing that to create a series of lines that are all equidistant. When you're done, press Enter to end the command. Let's undo. In the case of this room, I would like to offset this line over a distance equal to the width of the wall. So I could either measure the wall with the measure tool here and learn the distance, or I could click 2 points and have AutoCAD measure it for me within the offset command. Let's take the latter approach. Click Offset. Let's turn on Object Snap down here. Make sure you have Endpoint Snap selected and perpendicular. It says specify offset distance. Let's click this point and then move the cursor over a little bit until the perpendicular snap appears, and then click there. That has just input the wall thickness as the offset distance. Now I can select an object to offset, which would be this line. I'll click on the left side to create a new object there. Zoom in here and select this little piece of wall and offset it down by clicking below it, and then press Enter to end the command. Offset is extremely useful when you're laying out architectural plans. Now, let's talk about the mirror command. It also creates new objects based on the existing objects in your drawing. Its icon is located right here. Click Mirror. It says Select Objects. I'd like to mirror everything in the room with the exception of these two lines. So I'll hold down Shift and click these two lines to remove them from the selection set. Press Enter. Now it says specify first point of mirror line. Basically, we're going to draw this mirror line, which will act as the axis that we will reflect everything through. So click an arbitrary point over here somewhere and see what's happening. Look, the mirror line is shown with a dashed yellow, and if I rotate that, you're seeing that all of the selected objects are reflected through that axis onto the other side. Turn on ortho by pressing F8, and you can be sure that you'll be reflecting them across this vertical mirror axis. Click down here to specify the second point of the mirror line, and then you're asked if you want to erase the source objects. Yes or no. I'll say yes. Y. Enter. So everything got reflected around to the other side. That's not exactly what I intended, but it's a good first step with the mirror command. Let's go back. And this time, let's do it precisely so that we can get a matching room on the other side of this wall. To do that, we have to think ahead, though. We have to decide, okay, where is that mirror line going to be? It really should be in the middle of this wall. I'm going to draw a line segment across this gap to act as a temporary reference that we can use to establish the mirror line. Now, use the mirror command again, select everything, and then remove these two lines and this one from the selection set by holding down the Shift key and clicking on those objects. Then press Enter to exit Select Objects mode. Now you're prompted to specify the first point of the mirror line, and that would be at the midpoint of this segment. I'm going to hold down Shift and right-click and choose Midpoint right here. I'll turn on Ortho by pressing F8, and then I will click at some arbitrary point below to specify a vertical mirror axis. Now, erase source objects? No. No is the default, so just press Enter. And now everything has been mirrored around that axis that we defined. We can then come in here and erase this line, or perhaps better yet, undo. Move this line down to fill in that gap. And now we have a matching room on the left. In the next video, you'll learn about the lengthen and stretch commands that alter what you've already drawn. In this video, I'll show you how to use the stretch and lengthen commands. Of the two, I find stretch invaluable and lengthen less so. but it's important to explore all the tools in your toolbox. So let's take a look at Stretch. It's located right here. It says Select Objects. Now Stretch is unique amongst the modification commands in that you need to select objects with a crossing window to use Stretch properly. Let's say we want to make this room bigger. We can stretch this wall over to the right. To do that, we need to select it with a crossing window. I'll click a point down here and drag up to the left. The crossing window appears in green. I'll click to select all of those objects and then press Enter to exit selection mode. Now the command prompt says specify base point. I'll click some arbitrary point here in the middle of the room. Now I have ortho on right now. If I didn't have ortho on, the stretch would look something like this. It's not exactly what I want. I'll press F8 to toggle ortho on again. I can stretch this room over, as you can see interactively here. Click a second point to end the stretch command. Let's try it again. Press Enter to repeat the stretch command. Select all of this stuff in the middle. Enter. Specify a base point and stretch it over. So Stretch is very powerful. It lets you slide things over, make things a different size. And the key to remember here is that you have to use a crossing window. Lengthen is located on the Modify slide out down here. It says select an object to measure. I'll click this line right here. There are different ways that you can lengthen an object using a delta, which is like a difference in length, a percentage, a total length, or dynamically. I'll choose dynamic. It asks me to select the object again, and now you can see that I can lengthen it or shorten it, as the case may be, however much I need to, interactively. I'll click right here, and in this case I shortened the line. Press Enter to end the command. I don't tend to use lengthen myself because I prefer to use trim or extend, and those are the subjects of our next video. The trim and extend commands perform opposite functions. In this video, you will use them both. Open the room's sample file and draw a line across both of the rooms, like this. Turn off ortho so that you can draw a diagonal line. Now let's locate trim and extend. They're located right here on this flyout. Choose trim. It starts with a select objects prompt, or you can optionally select all the objects in the drawing. And I'll explain why you'd want to do that in a moment. But for now, let's select this object and then press Enter. The next step is to select the object to trim, or you can Shift Select to use the Extend command. I'm going to click right here, and that will trim off this part of the line. Now I can press Enter or Escape to finish the command. Let's try it again. Press Enter to repeat the command, and this time press Enter again to select all the objects in the drawing. This provides us with many different potential cutting edges. Now we can click things we want to trim. I could trim this piece and this piece, and you see it trims off where it intersects with another line. If I trim here, it gets rid of that piece, but you'll notice that I can't trim this piece because this segment spans between these two objects and there's nothing that cuts it. There's no object that goes through it. I'll press Enter to end the command. Let's draw another line like this. I'll use trim again, and I'll press Enter to select all the objects in the drawing as potential boundaries. And now this time, instead of trimming, I'm going to hold down the Shift key. This will invert the command so now it works like extend. Now, if I click here, I can extend the line. I'll let go of Shift now. I'll come over here and click here, and that will trim off that piece. I'll hold down Shift again, so that now we're dealing with the opposite command, extend. I'll click here, and the line will extend to the next boundary edge. Clicking again goes to the next boundary, and again to the next one. I can't do it another time because there's nothing that this would extend to and hit. I'll press Enter to end the command. This time, let's try the extend command. I'll select this particular object as a boundary and then Enter. Now I'm going to zoom in here to this little segment that's left over, and if I click right here, that little segment becomes a long segment that extends all the way to that boundary. Now it looks like it goes through it, but actually this is a separate piece that was left over from before. Let's try extend again. Extend. This time I'll press Enter to accept the default option, which is Select All. That selects everything as a potential boundary. Now I could extend this line, and again, all the way to the end. If I hold down Shift, I'm going to get the opposite command, which is trim. So I could trim away a piece. Here's another one I'll trim away. So in this way, you can extend lines or trim them off, and it really doesn't matter which command you use. You can use trim or extend, and you can get the benefit of its opposite command simply by holding down the Shift key. The way that I use this most of the time is I accept that default that says Select All, so that I can use all of the objects in the drawing as potential boundaries that I can then extend or trim my objects to meet. In very complex drawings where there's a lot of information on the screen, that might be a case where you want to manually select a particular boundary edge that you want to either trim or extend to. So take some time and experiment with these two commands and get a feeling for how they work. In the next video, we'll take a look at break and join. In this video, we'll examine the break and join commands. Open the room's sample file, and then expand the Modify slide out. Right here, you'll find break and break at point. The first icon has two blue dots. That means you can break in two places on a line. The second icon allows you to break at a single point. Let's try this one, break. It says select object. This command is unique in that the point that you select the object becomes the point at which you break the line. So if I click right here, it's going to break it there. And then it says specify second break point. And I'll click over here, and the command is done. The problem with this is that you can't use object snap at a select objects prompt, so you can't really be very accurate. I'll show you another method for breaking with accuracy. I'll draw a couple of vertical lines here and zoom in. And this time I'll use the command line version of the command. I'll just type BR for break, enter. It says select object. I'll select this object. And just like before, it broke it there. But now I'm going to use the first point option. It says specify first break point. I'll do that right here, perpendicular to this vertical line. Now I have accuracy because I was able to use object snap there. And I have perpendicular snap running. You can check that here. The command prompt says specify second breakpoint. I'll click right here to go perpendicular to that vertical line, and the command is done. Now alternatively, I could have just trimmed this line away. So that's another method. There are really lots of different ways to get the job done. Let's take a look at break at point. This allows you to break at a single point. So I'm going to select this object, and it says specify first breakpoint. I'll click right here. And now that object has been separated into two pieces. right at the point I clicked, right underneath it. If you want to be accurate, you can use Object Snap. Let's try that again using the command line version. I'll type BR for break, enter. I'll select this object, and I will specify the first point of the break, and I'd like that to be at the midpoint of this line. So I'm going to hold down Shift and right click, choose midpoint, and click right here. As you can see, I can break the line in either direction. However, in this case, I don't want to leave a gap. I just want to break it at the same point. Well, there's a shortcut for that. You can just type the @ symbol and press enter, and that indicates that you want to break it at the same point that you input previously. So now we have two pieces that were broken at the midpoint of that original line. Now we have two new pieces with two new midpoints, here and approximately here. We can rejoin broken objects with the join command. Type join, enter, select these two pieces, and press enter. Now it's whole again. You can even join lines that have a gap between them. I'll type join, and I'll select these two, and press enter. They're rejoined. There's still another broken piece over here, so I'll press enter and select these two, enter again, and now we have a single piece. You cannot join lines which are not collinear. So for example, I can't join this vertical line with this horizontal line. It might not be quite as obvious, but you can't join lines which they look almost collinear, like this one. I just drew that in freehand. It's parallel to this line, but it's off a little bit. So if I try to join it, it's not going to work. So sometimes you can be frustrated if you're trying to join two lines and it's just not working. Check to see if one of them isn't offset just really slightly from the other one. So to reconnect this whole drawing back to the way it was before, I'll type join. I'll join these two objects together, and then just erase these two lines. So there you have it. You can break lines at 1 or 2 points. You can do it roughly or with accuracy, and you can also join them back together. In the next video, we will edit objects using grips. Every object has grips that appear when you select it. For example, here in the Rooms sample file, I can click on this line and 3 blue grips appear. Grips provide an alternative interface for accessing 6 different modify commands. If I click this middle grip, I have then picked up the line. I'm actually stretching it, but because it's the midpoint of this line, it's essentially equivalent to moving the whole line. I have ortho on, so I'm just dragging it horizontally. I'll press F8 to turn off ortho, and you can see that I can reposition that object to a new location. If instead I click the top or bottom grip, when I move it, you'll see that this is more like a real stretch. It's really the same as if I had used the stretch command and made a crossing window around this point, like this. Stretch. Select that point, enter, click a base point, and then move it. The grips are just a little bit more efficient because you don't have to go up here and choose the right command. You can just click the object, click the grip, and stretch it. If you hold the mouse still over the grip, you'll get this shortcut menu. I can choose lengthen, and then I can dynamically shorten or lengthen the line, like that. The advantage with lengthen is that you can be assured that the line is in the same direction. You're not rotating it at all. When I lengthen, I can make it longer or shorter in that same varying angle. What might not be evident here at first glance is that you have access to many more commands. The way that this works is you click a grip, and if you notice down here it says stretch with asterisks around it. That means I'm in stretch mode. But you can actually cycle through several additional commands by pressing the space bar. I'll press the space bar and I get move. I'll press it again and I get rotate. Press it again and we have scale. Press it again and we have mirror. Pressing another time takes us back to stretch. And so we can keep going and cycling through these 5 editing commands: stretch, move, rotate, scale, and mirror. Of course, lengthen was also a choice, but it's only available in that shortcut menu that appears when you hover over a grip. So let's say I want to rotate this. I'm just going to keep hitting the space bar until I see the word rotate. And then I can use the rotate command with the base point already selected. It's that grip. So I can click right here to rotate the object around that point. Let's try rotating it around this other grip. I'll click here, press the space bar twice, and then I can rotate it around that point. I can also rotate it around the middle grip. Click there, press space bar, and then I can rotate. Pressing escape deselects all the grips. You can also manipulate multiple objects together. So for example, I'll click this object and this one. I'm going to hold the Shift key down and then click this grip and this grip. They both turn red to indicate that they're both hot. Now I let go of the Shift key and I'll click this one grip. I can then stretch, move, rotate, and so on, but now I have a selection of 2 objects that I can work on. And the grip that I clicked on is going to be the base point for all of these operations. So I can rotate these around that point if I so choose. So use grips as an alternative method for modifying objects. In the next video, you'll learn about boundary and overkill. I'll discuss the overkill and boundary commands in this video. First, let's tackle boundary. The boundary command is located up here on this flyout. It's grouped with hatch and gradient because it uses the same ray casting algorithm. Click boundary. That opens up this dialog box where you have a few choices. When you're creating a boundary, you can generate it as a polyline or a region. And I'll discuss regions in the next video. For now, let's have it generate a polyline. The boundary set is what you're going to analyze. In a really complex drawing, you might want to limit that to a smaller area. And you could do that by selecting a new boundary set and selecting certain objects that you want to analyze, like this. Press Enter. So now we have a selection set that we're going to analyze. Up here, we can click this button, and it will allow us to pick an internal point. The algorithm casts rays out from this point and determines the boundary of the room based on the point that you click. It works generally very well. If I click here, it automatically found the boundary. Places where this can fail are if there are any gaps in the line work. For example, if these lines didn't quite meet, there was a little infinitesimal gap there, this might not work. So it can be a bit frustrating if you're trying to find boundaries in spaces that aren't really precisely drawn. In any case, let's go ahead and press Enter and end the command. It generated a polyline, and just to prove that to you, I'm going to move it over so we can take a look at it. I'll click Move, and then select the last object that was created. Type L Enter, and that selects the polyline. I can then press Enter again and click 2 points to move that over. Sure enough, we have a polyline. Now this can be used to calculate an area, for example, although in a real project, we probably wouldn't want to include the door swing in the room area or to subtract it from the room. I'm going to press escape and undo back to the point where that boundary is on top of the existing line work. I'm also going to explode it. I'll click explode, select that polyline, and press enter. So now it's a series of lines and an arc. If you zoom in here and move the cursor over this wall, you'll see that it's made of 3 little pieces. This is not a good drafting practice. It's much better to join these pieces together. But the more complex your project becomes, the less likely you're going to have time for housekeeping issues like this. But fortunately, there's a way to clean this up automatically, and that is the overkill command. If you open up the Modify slide out, you'll find a tool down here which has a broom for its icon. Click it, select all the objects, press enter, and you're taken to this dialog box. I'm going to ignore the layer so that this is going to delete duplicates no matter what layer they're on. I'll click OK. And it tells me down below that 5 duplicates were deleted, 4 overlapping objects or segments were deleted. It's not perfect. It did a pretty good job. Let's take a look here. This is now a single line. However, I notice up here that this is the wrong color. I'm going to click on it and then press erase to get rid of it. But now the drawing is much more streamlined. I don't have those duplicate lines here anymore. One way you can check that is go erase and make a crossing window and see how many objects are selected. It says 1 found. So there's really only 1 line there now. We managed to clean up the drawing after doing the boundary command. In the next video, we'll work with regions. In this video, I'm going to discuss regions and the Boolean operations you can use to manipulate them. Begin in a blank drawing and draw a circle. The size doesn't matter. Draw a rectangle next to it. Draw an ellipse and a polygon. I'll draw a pentagon over here. At this point, these objects are defined only along their perimeters. The interior of these bounded objects is mathematically undefined, if you will. What we're going to do is convert these objects into regions, and then they'll truly be 2-dimensional objects. Once that's done, we can then use Boolean commands to manipulate them. And that's where it really gets interesting. So let's go ahead and expand the Draw slide out and click Region. Select all the objects you've drawn and press Enter. It says 4 regions created. You can only make a region out of something that has a closed boundary. You can't turn a line into a region because it doesn't contain an area. Now these objects are regions, but they look the same. The difference is subtle, and it's something that's a mathematical representation that's behind these objects. To use Boolean tools, which are named after a mathematician named George Boole, we will move the circle over so that it's overlapping the rectangle. Then type union. Select the circle and the rectangle and press Enter. The result is the common area of those 2 regions. This wouldn't have been possible before when we had just a circle and a rectangle. Boolean operations only work on regions or 3-dimensional volumes. Let's go ahead and move this object over so it's intersecting this other one. Now, let's try another Boolean command called intersect. Select both objects and press enter. The result is their common area, the area that they both share. Finally, there's one other Boolean command that you can use called subtract. I'll move this pentagon over here, and let's try out subtract. With subtract, the order that you select the objects is important. You need to select the object that you wish to have remain first. In this case, I'd like this object to remain. I'll press enter, and then I'll select this object and press enter. The pentagon is subtracted from the other form, leaving this complex shape. So, Booleans allow you to manipulate regions, and it's really quite interesting because you can use objects as tools that can alter the shape of your design. So Boolean tools are great in a conceptual design phase when you're trying to come up with an interesting form. And they're also useful in 3D modeling when you're dealing with 3D volumes. In the next video, I'll cover fillet, chamfer, and blend. Fillet, chamfer, and blend are 3 commands used to create transitions between lines. Open the line sample file in the Chapter 5 folder. The 3 commands I mentioned are here on this flyout: fillet, chamfer, and blend. The icons give you an idea for what these commands do. Fillet creates an arc transition between objects. Chamfer makes a straight line, which can act like a beveled edge. And blend inserts a spline between objects. Let's begin with fillet. The prompt says select first object. Before I actually use this command, I need to set the fillet radius down here with the radius option. So I'm going to click radius, and I can type in a value here, or I can click 2 points on screen to specify that distance. I'll take this latter approach. I click 2 points about at the same scale as this gap between the lines. Now it says select first object, so I'll click this line and then select the second object over here, and the preview image shows you what's going to happen. There's going to be an arc inserted between these lines. I'll repeat the command by pressing enter. This time I'm going to set the fillet radius to 0. I'll click radius on the command line and type 0, enter. When you have a fillet radius of 0, no arc will be created. I can click these 2 lines, and they're joined in a sharp corner. I'll press enter to repeat the command. It's important that you click the lines on the portions of them that you wish to keep. So if I click this line here, and this line over here, it's going to trim away those lower portions of the line segments. If, however, I click this line down here, it's going to trim away the top half. So the rule of thumb is always to click the part that you want to keep. Let's try chamfer next. Chamfer works with 2 distances. So let's set the distance option here. Normally, you would set these distances equal, but it's possible to have them with different values. It says specify first chamfer distance. I'll click 2 points to set that value. And that value is immediately inserted as the default, so I can just press enter to accept that as the second distance. Now it says select first line and second line. So the 2 distance values correspond to the distance from this point to a point right about here where these lines would intersect. And the second distance is from this point to this point. Because those 2 distances are equal, we have a symmetric beveled edge here between these 2 lines. I'll press enter to repeat the chamfer command. And then over here, if I try to chamfer these 2 lines together like this, I can't do it. You'll see a circle with a line through it symbol, meaning it's impossible. And that's because the distance is just too large. So we can go down here and click distance, and I'll set the distance to a small value. I'll click 2 points that are close together like this, and then press enter to accept that smaller value for the second distance. Then I can come over here and click this line, and we'll have a smaller chamfered edge. Now blend creates a spline transition. We'll use the blend command here. And we don't need to set any values for this. I'll click this first object and the second object. A blend curve is inserted, and I'll just zoom in there. And you'll see that it has a complex curvature. It's not a section of a circle. And if you click on it, you'll see that it's a spline. In this case, it's a control vertex spline. It has tangency here and here. And that's what gives this object its smooth appearance. I'll press escape and zoom back out. So there you have it, 3 different ways that you can join lines together using arcs, beveled edges, or splines. In the next video, we'll discuss divide and measure. In this video, we'll explore the divide and measure commands. Both of them output point objects, which can be snapped to, and you can use these commands to help you lay out objects. So open the architectural sample file in the Chapter 5 folder, and let's say that we wanted to add some stools to this kitchen island. Let's copy one of the chairs from outside on the patio into the kitchen. Click Copy, select this chair, Enter, and click a base point and a second point. Then zoom in there into the kitchen. And now I'd like to have maybe 3 chairs here that are all equally spaced on this counter. We can use divide to help us determine how to do that. Type div for divide and press enter. It says select object to divide. That would be this edge. Enter the number of segments. Let's try 4. I pressed enter and now the command is done, and seemingly nothing has happened. But actually, the divide command has created 3 point objects. You can just see them right here, here, and here. However, the points are displayed as single pixels, so it can be hard to see, and in some cases it would be impossible to see if the current layer was the same color as the object you're dividing. Here we have the current layer is set to 0, which is white, so I can just see these 3 white pixels along the edge. However, there's a better way to see point objects. You can use the little-known ddptype command, which stands for Dialog Box Command Point Type. Here we have it. You can select any one of these shapes to represent points. I like this one. I'll click it and just click OK. And now we see all of the points in the drawing are displayed with this symbol. Evidently there are point objects on the corners of this stove, and some over here on the sink. So at least while I'm laying this out, I'll leave the points displayed with this big symbol. And maybe when I'm done, I'll set it back to a single pixel. So now I can move the chair, and I could just eyeball it like this and make 2 more copies. Or I could be more exact and use object snap. I'll zoom in here and let's just be exact. We'll move this chair from a base point, which is right here in the middle, so I need to use midpoint snap. Hold down Shift and right click to open up this menu and select midpoint, and click right here to pick up the chair from that base point. Now I want to snap it to that point. Points have node snap. So Shift, right click, and choose node. Then you can snap directly to the point, like that. Copy the chair, enter, and now I can snap it from node to node. For this, to save a little time, I'm going to turn on running object snap node. That way I don't have to keep calling for it by holding down Shift and then right-clicking every time I want to use it. So now I can specify the base point at this node, and then the second point at this node. And I can keep going and click this node, and then press Enter to end the copy command. Now, maybe I need to pull those chairs out from the counter a little bit. I will select all three of them with a crossing window, Enter, and then I'll move them using ortho. So I'll press F8 to toggle ortho mode on and just drag them to the right a short distance. Now I could go ahead and erase these points. I'll click Erase, and then make a window around the points and get rid of them. Another way we could lay out these stools is using a set distance between them. We can use the measure command to insert points a measured distance apart. So let's go ahead and type in measure. We will measure this line, and the length between these segments will be, let's try 3 feet. See how that looks. I'll type 3 apostrophe, Enter, and it has inserted 3 point objects. So the distance between this end point and this point here is 3 feet, and then we have another 3 feet, another 3 feet, and then we have whatever's left over. So the measure command can create this type of arrangement, but it's going to leave you with a remainder. This is the remainder here, this distance. So in this case, where we're trying to center 3 chairs on a kitchen island, divide is the better command. But there are some circumstances where you'd be better off using measure when you need to ensure that there's a set distance between objects. So I could erase the points or just go back to DDP type and change the representation of points to either a single pixel or nothing at all. Here I'll use nothing at all, and all of the points will disappear. They're still there, however, but I can't select them. They're available should we know about DDP type and go ahead and turn them on so that we can use the points for layout purposes. So there you have it, 2 commands that are really useful for layout, divide and measure. In the next video, we'll take a look at commands used to edit polylines and splines. In this video, we'll explore the pedit and spline edit commands. These can be used to give you greater editing power over polylines and splines respectively. Open the map sample file in the Chapter 5 folder. This is an image overlay of Maui, Hawaii. Let's zoom in on the northern coastline. And you'll see that the map is quite pixelated. Let's trace over some of the coastline with a polyline. Click Polyline on the Draw panel and start tracing the edge. In areas where there's greater curvature, you'll probably want to click more points. And in areas where it's a little flatter, fewer points will suffice. I'm just going to trace a small portion of the coastline. I'll press Enter to complete the pedit command. Now, zoom in and select the polyline. You could convert these segments to arcs by positioning the cursor over these midpoint grips and choosing Convert to Arc. This is going to more accurately represent the coastline, but it's going to be far too tedious to have to go in here and convert all these different segments to arcs. Fortunately, there is a better way, and that is to use the pedit command. There's a shortcut to launching that command, and that is to position the cursor over the polyline, but not over one of its grips. So just like right here, double-click, and that will automatically execute the pedit command, which stands for Polyline Edit. Let's choose the spline option, and then press Enter. This automatically curves the polyline, and this looks a lot better. Select it, and you'll see a series of blue grips appear. This is not a true spline object. It's still a polyline, but we have some functionality that's similar to a CV spline. We can reposition these vertices and more accurately capture the curvature of the coastline. Press Escape. You'll have even greater editing power if you convert this to a true spline. And you can do that very easily with the spline edit command. So type spline edit. It's all one word, no spaces, and there's not a doubling of E's. So you type the word spline and then DIT for spline edit. It says select spline. This is actually a polyline that has been altered with the spline option of the pedit command, but this will work. Select it. And that's all it took. Now it is a true spline. You can tell that because the grips have changed their appearance. Now the grips are these little round blue grips, which are CVs. Press Enter to exit out of the spline edit command. Now we can zoom in a little more and adjust some of the CVs to control the curvature. Now there might be some areas here, like over here, where the curvature isn't that great. We can use Spline Edit to control the weight at particular CVs. Just like we did with the polyline, we can position the cursor over the curve and double click. That will automatically execute the Spline Edit command. Let's choose Edit Vertex and then press Weight. In this mode, we can change the curvature locally around a particular CV. And what we do is we want to locate the proper CV. Right now, this CV is red over here. That means it's the current control vertex. I want to go to the next vertex, and that's the default option, N. N is for next. So just press Enter, and you go to the next vertex. I'm going to keep pressing Enter many times until I get around here to this particular vertex. Now I'd like to pull the curve closer to that CV, and I can do that with a weight value. By default, the CVs all have a weight of 1. If we increase that value, the curve will approach the CV. Let's try a value of 3. The curve got pulled closer to the current CV. I can go previous, to go back to this earlier CV, and I can change its weight value to 2. That pulls the curve closer to it. But if you notice, this curve got pulled back. It's because the weights are shared amongst the CVs. And so when I pull on the curve on one, it kind of tugs back on the curve that's altered over here. It's a little bit hard to explain, but fairly easy to see. Now I'm going to get out of this mode, and we actually have to exit, and then exit again, and then exit a third time to get all the way out of the command. Something you might want to do is join splines or polylines together. Tracing the whole island of Maui is quite a task here, as it has a lot of curvature, and so you probably don't want to tackle that all in one go. You could do it in parts and then join the parts together. So for example, I can keep drawing either a polyline or a spline here, and then you know how to convert the polyline into a spline if you need to with the spline edit command and the spline option of the pedit command. But in this case, I think all I'm going to do is draw a spline directly. I'll type spline and then connect it to the previous one so that the first point is snapped to the end point there. And then I'll just start drawing a true spline object here. I'll go a little bit more down the way here. And let's say, okay, I'm tired, I'm going to stop. I'll press Enter. But then I'd like to join these two pieces together. I will select one of the pieces, double click on its edge to execute Spline Edit, and say Join, and then select the other piece and press Enter. Now it's all one spline. I'll press Enter to exit the command. So there you have it, 2 editing commands, pedit and spline edit, that give you maximum control over the curvature of your objects. In this video, we'll explore Grid and Snap. These two features allow you to draw objects constrained in space. Go down here to the status bar and toggle on these two modes, Grid and Snap. To control their spacing, click this arrow and choose Snap Settings. This opens up the Drafting Settings dialog box, and we're focused on the Snap and Grid tab. You can toggle on and off Snap with F9, and you can toggle Grid with F7. By default, the snap spacing is 0.5 centimeter in both X and Y directions. And Grid is the same. Let's change Grid so that we see a grid line every centimeter. So I'll type 1 tab here. And I'd also like to set up the grid so that there's a major line every 10 centimeters. So I'll change this to 10. If we were using inches, it would be best to set a major line every 12 inches or every foot. Over here, this is a major line, and these are minor lines inside. I'm going to leave adaptive grid checked so that the grid density is limited when you zoom out. And I'll leave this unchecked so that the grid won't subdivide smaller than 1 centimeter. Let's make sure that we have Grid Snap and Rectangular Snap selected and click OK. So now what we're looking at is a grid with major lines every 10 centimeters. So each little box inside of here must be a square centimeter. And if you zoom in by rolling the mouse wheel, you'll see that the grid does not subdivide below a centimeter. I'll zoom out, and at a certain point, things get simplified. So we're not looking at the individual centimeters anymore. We're just looking at every 10 centimeters. I'll zoom back in a bit. This gives us a good visual indication, just like graph paper does, of the regular organization of space. Let's go ahead and draw a line. And as I move the cursor, notice what's happening. It's sort of jumping. That's because of snap. We're snapping to every 0.5 centimeter. You see that? I can snap to these intersection points of the minor lines, and I can also snap midway between them. So I can draw a line along here, and I can tell just how far it is. And I don't have to enter any numeric values. I can just rely on Grid to help me determine how big things are. And I'll just go ahead and draw a rectangle and press Enter to end that line command. So it can be nice to use Snap in situations where your geometry happens to conform to such a scheme. And I'd say generally that's rare unless you're making mechanical parts that just happen to come in 0.5 centimeter increments. A more flexible approach that we'll cover in a future video is Object Snap, and that allows you to snap directly to geometry that you draw in space. But this more primitive or more fundamental system of Grid and Snap allows you to draw objects that happen to conform to a regular grid. So let's go ahead and draw another line here. And you see that I can't draw it to any place other than this spatial grid. If I wanted to, for some reason, draw a line to some other arbitrary point, I would have to come down here and toggle off Snap. Now the cursor moves smoothly and I can click anywhere I want. Alternatively, we could hide the grid and use Snap. And then we have that sort of implied grid. Although we don't see it, it's still there and it's still operative. And we don't have to use ortho and we don't have to use Object Snap. So there you have it, Grid and Snap, two aids that assist when you're creating objects that happen to conform to a spatial grid. In this video, we'll create an isometric drawing. Isometric drawings are two-dimensional illusions that represent three-dimensional objects, but they're not truly 3D models. This is perfect for AutoCAD LT, which doesn't support 3D modeling. you can actually represent a 3D object in isometric. To enable this in AutoCAD, you need to turn on a status bar toggle called the isoplane, and you can access that on the Customization menu under Isometric Drafting. That adds this control to the status bar. It contains 3 different planes, left, top, and right. We'll start with the left plane. Click here to enable isometric mode. The icon changes to a red and green symbol. The cursor also matches that. The x-axis is red and the y is green. Let's also turn on ortho and snap. Draw a line, and let's draw the left side of a mechanical part. We're viewing it from above and at an oblique angle. Now I need to change the isoplane so that I can draw the top. Draw another line and snap it to what you've already drawn. Now here I overshot. This is easy to do because it's hard to line it up. I'm going to move this over, and unfortunately it didn't make it. Let's try another method. Erase the line, draw another line, and I'm having trouble snapping here. So I'm not able to use grid snap. I'm going to have to resort to object snap. Hold down Shift and right click and choose endpoint. Then select this particular endpoint. Let's draw another line from here, and this time the intersection corresponds with a snap point, which is tied to the spatial grid. And then I'll do another one here, and evidently this point doesn't correspond to a snap point either, so I'll have to use object snap. Hold down Shift and right click, choose endpoint, snap to that point, and draw a line over. I'll draw another line down here using the same method. And then we should be able to draw lines to connect these in the right view. So we need to change the isoplane to right, and then use the line tool again. Here I need to snap to the intersection, right there. And it looks like I'm drawing the left side again. So I could just copy what I've already drawn here from here over here, but I'm going to have to snap it to endpoint there. Now we need to clean up these lines which overshot their targets. To do that quickly and easily, I'll type TR for trim, enter, and press enter again to select all the objects as boundaries, and then I can simply click on the parts of the lines that I don't want. So there we have it, a isometric drawing that represents a 3-dimensional object on a 2-dimensional surface. If you want to go back to the way the coordinate system was before, you have to toggle off isometric drafting and the cursor returns to normal. In the next video, I'll go into more detail about coordinate systems. In this video, I'll discuss coordinate systems. Coordinate systems are used to measure objects, and there are 2 primary systems that we use in AutoCAD. Cartesian, named after René Descartes, the famous Enlightenment philosopher and mathematician, and polar. AutoCAD also supports cylindrical and spherical coordinate systems, but these are only used in 3D modeling. We use Cartesian and polar coordinates all the time. In fact, they're both operative when you do something as simple as draw a line. Click the line tool, and turn on dynamic input down here on the status bar if it's not already on. What you're seeing here are 2 numbers representing x and y coordinates. This is the Cartesian system. René Descartes came up with this idea that we could represent any point in space as a combination of these 2 values, x for the horizontal axis and y for the vertical axis. In AutoCAD, we can use dynamic input to see those graphically, or to type in numbers directly. I'll type in 15 tab 10 to specify some absolute coordinates. So this initial point is 15 units over in x and 10 units up in y relative to the origin point of the grid. Normally we don't do that. We don't care where a line starts from. But I'm just highlighting this to show you that you can actually input absolute coordinates here. Cartesian coordinates aren't so useful when you're drawing lines, but they're more useful when you draw rectangles, and we'll do that shortly. Right now, for the next point of the line, AutoCAD has automatically switched over to using the polar coordinate system because it's much more useful at this stage. When we're drawing lines, we generally don't care about their x and y coordinates. Instead, we're more concerned with how long the lines are. So the polar coordinate system measures the distance away from the pole, that is, the initial point. If I bring the cursor down here, you can see the value gets really small. If I move it further away, it gets longer. The other portion of polar coordinates is the angle, and you can see that value changing as I move the cursor. So we can enter these values by typing 15 tab 33.3, enter. And so I've specified that second endpoint using polar coordinates. Let's draw a rectangle next. I'll specify its first corner point at some arbitrary location. I'm not concerned with the absolute location of that relative to the origin point. But the next point is relative to the first point. You see, the next point values are relative to that first point. If I bring the cursor right back here, I get all the way down to 0, 0. So it's almost like the origin point is that first point that I clicked. So the second point is going to be determined by the length and width, or x and y coordinates. So I can type in 15 tab 10, enter, and then we know for a fact that this rectangle is 15 units wide and 10 units high. We don't really care where it is relative to the origin point. Now let's say I want to draw a line from the origin point so I can see where it is. I'll type L, enter, 0, 0. The comma is used as a delimiter to separate the x and y coordinates. It's an alternative to using the tab key with dynamic input. The advantage to using the comma is it works even when you're not using dynamic input. So there's the origin point. We can verify that also by turning on the user coordinate system icon. Type UCS for user coordinate system and then icon. Turn that on and you'll see it right here. It represents the directions for the x and y axes. And the point right there is the origin point of the grid. I'll turn on the grid and you can see that it lines up there. It's important also to be able to type in Cartesian or polar coordinates on the keyboard. So let me show you how to do that next. Draw a line from some arbitrary location, and I'll use the keyboard to type in Cartesian coordinates. Even though dynamic input is showing me polar coordinates, it doesn't matter. I'll type in 5, 10, and that forces it to use Cartesian coordinates. Enter. So now I know this endpoint is 5 units over and 10 units up from that first point. I'll draw a rectangle, and this time I'll use polar coordinates to locate the opposite corner. I'll type 10, and then I'll use the angle symbol. On the keyboard, it's the less than symbol above the comma key, so I have to press Shift, comma, and you'll see that little angle symbol there. Now it's forced AutoCAD to use the polar system. So I'll say 10, angle 45, enter. And so now this is a square because this distance is 10 units across from corner to corner, and it's at a 45-degree angle. So you can choose which type of coordinate system you want to use, depending on whether you type a comma or an angle symbol to differentiate between Cartesian and polar coordinates. In the next video, we'll talk about ortho and polar used in conjunction with direct distance entry. In this video, we'll take a look at polar tracking and compare it with ortho. Start by drawing a line and turn ortho on down here on the status bar. As the icon suggests, ortho constrains your drawing to orthogonal 90-degree increments. So if I draw a line here, I can only draw it horizontally or vertically. I can click points here without having to worry about the angle. I can just type in a distance, say 12, and press enter, and AutoCAD will draw it horizontally. If I move the cursor down in this direction and I type 12, enter, it's going to understand that I want to draw it down because of the location of my cursor. So if I move the cursor over this way and I type 20, enter, there's no need for me to type in the angle because ortho is taking care of that for me. So ortho is used quite a lot because most objects that are manufactured have right angles. Most buildings have right angles for the walls, and so this is quite handy. However, there are many situations where you will want objects to meet at something other than a right angle, and you would use polar tracking for that. Let's turn off ortho and turn on the neighboring icon, which is polar tracking. Polar tracking is controlled with this menu, and you have different sets of angles you can snap to. Let's start by selecting this top option, 90, 180, 270, 360, and so on. That's very similar to the way that ortho works. Draw a line from some arbitrary point and see what happens here. We have a green dashed line representing the polar tracking, and it works very much like ortho. I can type in a distance, say 10, and press enter, and AutoCAD will draw that horizontally. However, I have more flexibility here because I can actually draw a line at any angle that I want. I can draw one up here, I can draw one over there, but I can, if I want, snap to this green dashed line. I can draw a line down here that's 6 units long. I'll type 6, enter, and there's no need for me to type in the angle value. Of course, you can override this at any time by typing in values. I could say 10, angle symbol, 15, to draw a line 10 units long at a 15-degree angle. You can change the set of angles here to a smaller increment. Let's try 30, 60, 90, 120, and so on. And now I can go ahead and draw lines with more choices here for the angle that I'm going to snap to. So depending on what you're drawing, you basically just look at it and say, okay, does this conform to some kind of polar orientation? Like, are there a lot of angles that are 30-degree angles, or are they 45-degree angles? And you just choose the right sequence of angles here. You can also set up your own angles. If you have some odd angles, you can add them in here by clicking New. You can toggle polar tracking on and off with the F10 key. In the next video, we'll go over the dynamic input system in more detail. If you've been watching the videos in this course in a linear fashion, you've seen me use dynamic input many times. But if you're jumping in here, I'll show you how to use this system, and I'll give you even more detail about how it works. So let's draw a line. And right now, I'm seeing the dynamic input. That's controlled here with this status bar toggle. When that's off, I don't see that information next to the cursor. When it's on, we have the command prompt. It says the same thing down there on the command line, specify first point. And we also see 2 coordinate values for the X and Y coordinates. As I go through the command, it switched to the polar coordinate system. And it also is reading me the prompt, specify next point or down arrow. There's one option at this stage, which is undo. Right here, I can click that on the command line, or I can press the down arrow on the keyboard to open up this menu where I could choose undo here. Alternatively, I could type in U enter on the keyboard to execute that option also. So there's no shortage of options here. Some people like the dynamic input prompt because it's right there where you're working in front of you, and others find it distracting. It's really a personal preference. I'm going to right-click on this icon and choose Dynamic Input Settings. It's going to bring me here to the Drafting Settings dialog box where I have lots of detail about how to control what I'm seeing here. Now let's say I disable pointer input. See what happens now. If I draw a line, it doesn't say anything. I can click a point, and now it displays the polar coordinate system, just like it did before. But it doesn't bother me with that initial information. So in a way, that's better. But if you're a new user, you might want to leave that on. Let's go back there again. Right-click on the icon and go back to Dynamic Input Settings. Now I'd like to re-enable that and go to Settings. Here is where you can control whether the second point is shown in polar format or Cartesian format, and whether it's relative or absolute. I think the best option here is already selected, polar and relative, because the second point that you click really should be relative to the first one that you've already entered. And it's usually most useful to use polar format for that, but you have the option. Also here, you can choose to display the tooltips all the time, or only when you're asked for a point, or as soon as you type anything. So again, choices are many. Here we can type in values when we're drawing a line. We have a dimension value. We can input a number there, and I find this very helpful. But you can turn that off if you don't like it. And you can adjust the settings here so that it just shows one dimension at a time or two. Let's try one. Okay, draw another line. Now it just shows me the length. It doesn't show me the angle. If I specified a length, say 10, and pressed Tab, it would show me the angle. But I sort of have to know that that's a possibility. And so if you're just starting out with AutoCAD, that might be a bit confusing. But as you gain experience with the program, you might like to streamline it a bit so that there's not so much visual clutter on the screen. And so that's what some of these options are used for. I'll just go back in there and turn that back on. Finally, you can show command prompting and command input near the crosshairs or not. That's the prompt. If I turn that off, it's not going to bother me with repeating what it says on the command line. It doesn't say specify first point anymore. In a way, that's appreciated because I don't like to have duplicate information on the screen. But again, it's up to you, and perhaps when you're learning, you might want to leave everything as it is. And as I said, as you gain experience, you can turn off some of these prompts, which you might find to be distracting. In the next video, we'll examine Object Snap. Object Snap allows you to precisely connect objects using the geometry itself as the guide. In this video, you will see several manual and automatic methods of using Object Snap. Open the mechanical sample file from the Chapter 6 folder. We have a top view and a right view of this part. I'd like to draw the front view. To do that, I'm going to find it easiest if I snap to the existing geometry and project the lines over and down so that I can construct this front view. I'll start by drawing a line, and the first point will be snapped to something up here on the top view. You can call for snap one at a time by holding down the Shift key and right-clicking. This opens up the Object Snap menu. I'll choose Endpoint. And then as I bring the cursor closer to this geometry, you'll see that a green box will appear. This is the endpoint symbol, and if you hold the cursor still for a moment, you'll see a tooltip that reinforces that fact, endpoint. Many of these objects have endpoints, and so you can snap to any of them. There are no endpoints on the circles, of course, but there are endpoints on the end of the lines and the end of the arcs, and everywhere you have the end of a line, you have an endpoint. So in this case, I'll snap a line to this endpoint, and with ortho on, I can project it down, and then press Enter to end the command. Now I'd like to draw a line over horizontally from this point, and I'll do that again. L, Enter, and I'm finding it a little bit tiresome to have to hold down Shift and right-click. You can type in 3-letter abbreviations for the object snaps if you prefer. So I could just type END for end, Enter, and now I have endpoint snap available. If you're finding that you are calling for a specific snap over and over again, which would be the case in this project, it makes more sense to turn on automatic or running object snap. And you can accomplish that right here. Click on this arrow and you'll get a menu of object snaps just like you do when you hold down Shift and right click. But this menu refers to snaps that are on continuously. So if I turn on endpoint here, it's going to stay on until I toggle it off. So now I'll draw another line, this time from this point down, and another one here. And you see this method saves a lot of time because I don't have to keep calling for the snap over and over again. You can toggle on multiple modes simultaneously. So I could turn on midpoint, center, quadrant, and intersection. Let's see what they do. I'll draw a line from the midpoint here over. I'll draw a line from the center of the circle. That appeared when I moved the cursor over the circle. It realized, oh, there's a center, I'm going to display it, and there it is. If I move the cursor over here towards this circle, it will suddenly display its center point. Every circle also has 4 quadrant points located at the north, south, west, and east points of the circle, if you will, every 90 degrees. That's also true for arcs. Arcs also have quadrant points if they go through those angles. In this case, this arc doesn't because it has an end point, which is essentially where its quadrant point would be. It also has a midpoint, and circles don't have midpoints. So I could draw a line from that quadrant over if I wanted to. You can also connect objects to intersections of other objects. So right here I have these intersections that exist now that I've crossed lines. So I could draw lines connecting them like that. This isn't exactly the right projection, but I'm just demonstrating the use of snap here. Now, another useful snap is called perpendicular. And I can draw a line from any arbitrary point over here, and then I can snap it to be perpendicular to this line. So it's precisely connected there. Whenever you snap, the objects are connected absolutely exactly to 8 decimals of precision. So you're not going to find any gap in there, no matter how closely you zoom in. The way that object snaps work is with the green symbols. So if I bring the cursor over here and I see that green symbol, I can click now and it will snap to go perpendicular. There's no need to try to bring the cursor in as close as you can. As long as the green symbol is illuminated, you are assured of having that snap happen if you click. Now, one snap to be cautious of is nearest. I'll turn that on and just show you how that works. If I click a line here, I can snap it nearest. That means anywhere along the line. I can also go perpendicular. But what tends to happen if you have nearest on as a running object snap is it will occasionally interfere with another snap. Like if I was here and I clicked right there and I thought it was going to go perpendicular, it might not actually be perpendicular. It might be nearest. So because of that potential for confusion or for a mistake, I recommend that you don't use nearest as a running snap. Instead, if you need nearest, call for it explicitly by holding down Shift and right-clicking, for example. So if I wanted to draw a line from here to some point along this line, I would hold down Shift, right-click, and click nearest here from this menu. Alternatively, I could draw a line and then type NEA, the first 3 letters of the word nearest, and then that would work just as well. You may notice that there is another snap called none. If I draw a line here, and I don't really want to go perpendicular there, but I want to draw it close to that, I could then hold down Shift, right-click, and choose none. And just for this moment, while I'm finishing up this command, none of the object snaps will work. I can then click it really close to that line, but it won't go perpendicular so that it's joined. So this is how you can override all of the running object snaps on a one-off situation. You can call for a none snap. Alternatively, you could just toggle off all of the snaps by clicking this icon. And then you can click there without snapping. But then you have to come back and toggle them back on. An even faster way is to use the F3 key. It toggles snap on and off. So you can be drawing and say, oh, I don't want to snap there. I'll just press F3, and then you can avoid snapping. So I recommend leaving many of these modes running. You can leave probably all of these on. I don't tend to use apparent intersection or parallel very often. Apparent intersection is something that happens in 3D when something looks like it intersects from a certain angle, but it doesn't actually intersect. And parallel isn't something you need very often. You can just offset a line. An extension is kind of an interesting snap because it's going to snap to a point that would exist if the line were longer. So let me show you that. I'll draw a line from here up here, and I need to turn on snap as well, F3. Now I can snap right there to that apparent intersection. The lines don't actually intersect, but there's a little X there that means I can snap to that point. And that's happening because of the extension snap. Point objects use the node snap, and text objects and blocks have insertion point snap. Tangent snap refers to a single point of intersection between an arc or a circle and a line. So, for example, over here, if I draw a line tangent to this circle, it will cross through that circle in exactly one point. So there are two tangents on this circle. There's one there, and there's one down here relative to the first point that I clicked on the line. So object snaps are extremely helpful in AutoCAD, and I use them every day. I recommend that you get used to them. It obviates most of the need for using grid and snap over here. Object snap is much more flexible. I would only use this kind of snap if the part I was drawing conformed rigorously to a grid, and that's rare. Most of the time, objects don't perfectly correspond to a grid, and you're going to want to use object snap instead. So there you have it, my whirlwind tour of object snap. In the next video, we'll take a look at a specific type of object snap called from snap, and we'll also look at temporary construction geometry. AutoCAD 2016 has a new type of object snap called geometric center, and this works on closed polylines, which I've drawn here on the left. As you see, I also have a circle on the right. Let's say we want to draw a line connecting the geometric center of the closed polyline with the center of the circle. Go to the Line tool, hold down the Shift key and right-click to open up this Object Snap menu. Choose Geometric Center, and position the cursor over the polyline edge, and you'll see this Geometric Center icon appear, which has these 8 points. I can click right here to snap to the geometric center. Hold down Shift and right-click again and choose Center, and then click on the edge of the circle to snap to its center, and press Enter to end the command. If I select the polyline and change its shape, obviously its geometric center is now in a different location. I can toggle on the running object snap mode, geometric center. Notice that center is also running. Now I can draw another line from the center of the circle to the geometric center of the closed polyline. But actually, when I did that, I clicked a little bit too close to the endpoint, and it decided to snap there instead, because endpoint is also one of my running object snap modes. So I've got to be a little bit more careful. Let me erase that line. Try again. Line from the center to the geometric center. I'm going to come over here and actually click on it. And now they're connected. The geometric center can be useful when you're calculating the center of mass of an object. It analyzes the two-dimensional shape and finds the center point. There's one other place you can find the geometric center, and that is in the Drafting Settings dialog box, which you can access by going to this item in the list, Object Snap Settings. It's listed right here, along with all the other running object snap modes. In this video, I'll talk about From Object Snap and some temporary construction objects that you can optionally create to lay out your drawings. Let's say that I wanted to start this drawing of the front view at a point that is 10 units over from this particular point right here at the intersection of the arc and this line. Now I could just draw a line there and snap it to that point. And using ortho, I can move the cursor to the left and type 10, enter, and that identifies a new point to start drawing my front view from. I could then draw a rectangle and snap it right there and continue drawing the front view. Alternatively, I could identify this point using From Object Snap. And the advantage to that is that I don't have to come in here later and erase this particular line segment that I used as a construction geometry. Let me show you how that would work. I'll draw a line, but instead of snapping it to this point, I'm going to shift, right-click, and choose From. From is going to defer the point that I'm going to snap to until later. I'm going to click here, and this is actually the quadrant point of the circle. And if I move the cursor slightly, it will shift to the end point of the line. And if I move it around some more, we'll see the intersection of the arc and the line. All three of those snaps are coincident, so it doesn't matter which one you click. I'll click here, and now the prompt says offset, and it gives me 2 coordinate values. I want to specify a point that is 10 units to the left horizontally from the point that I clicked. So I can do that using either Cartesian or polar coordinates, whichever you're most comfortable with. In this case, I'll use Cartesian, and I want to use relative rather than absolute, so I'm going to have to type in the @ symbol to specify that I want relative coordinates, that is relative to the first point that I clicked. Now I'll type in -10, so that means move to the left along the x-axis, comma, 0. So I don't want to move up or down in the y-axis at all. I just want to move to the left 10 units relative to the first point that I clicked. Now I'll press enter, and the line begins from that point that I'm looking for. So this method has a bit more overhead associated with it because you have to think about, okay, how am I going to specify that point? I'm going to have to type in coordinate values. Okay, so I don't know if I would use this method. I think I'm more inclined to just draw some temporary geometry and then erase it later. That seems to be more straightforward to me. But From is there in case you want to skip that step and specify an exact point that isn't actually on an object. So this is interesting. You're using Object Snap in a way where you're able to snap to points that aren't even on objects using From Snap. Now let me show you a couple of other ways you can create temporary construction geometry that you will erase later. So let's say I want to lay out this drawing over here. And to do that, I'm going to have to draw a bunch of lines. So I could either draw those lines or I could use some aids here that are available on the Draw slide out. There's 2 of them here, construction line and ray. Let's start with construction line. it will actually make a line which is infinite in length. And all you have to do is specify a point where it starts and a direction. So if I click right here on this endpoint and move the cursor down and click, I have drawn it. Now I will press the space bar to end the command. And just to show you, I'll zoom out. It doesn't matter how far out I go, this line will go on forever and it will always go off the screen. Well, that's fine. I don't really know how long the line is supposed to be yet. So it's helpful just to draw some construction lines here. I'll go ahead and offset that. I'll use the offset tool. And then I'll offset that from here to here. And I'll just go ahead and offset that. And I can have an additional construction line there. Now I might want to draw yet another construction line. And the command on the keyboard is X-line. And I'll click here, and then using ortho, I'll click to the left to create another one. And then again down here, and again over here. So I've blocked out my front view using these temporary construction lines. Now if I use trim, I can then cut away at these construction lines and make them of finite length. I'll press the default select all by pressing enter to select everything in the drawing as a potential boundary, and then I can go ahead and trim away some of these construction lines. Now, if you zoom out, you'll see what happened. I cut away these okay, but this one continues on, so I'm just going to have to erase that one. Now over here, these seem to go off the screen forever, and they're not construction lines, they are rays. This is a ray because it starts at a point and goes on forever in one direction. And I can convert that into a line by trimming it. So I'll choose trim. I'll select this construction line particularly as the boundary and then press enter. Then I'll trim these two rays off. Press enter again. And now these have been converted into lines that have a fixed length. I'll go ahead and trim again, click trim, enter, and then I will just trim these off. But this method left me with these rays that up here that I need to then delete. I did that by making a crossing selection and by pressing the delete key on the keyboard. It's an alternative to using the formal erase command. So in this method, I've locked out my front view diagram using some construction geometry. You also learned how to use the from snap to specify a point, a set distance away from a given object snap. In the next video, we'll take a look at object snap tracking. Object snap tracking is like having temporary construction geometry that erases itself after you're done laying out a drawing. In this video, you will track points and snap to them. Open the mechanical sample file in the Chapter 6 folder. Then turn on Object Snap Tracking down here on the status bar. It's adjacent to Object Snap. Let's also have Ortho on. And then go ahead and click the Line tool. Move the cursor over here to acquire a tracking point. The snap could say quadrant, endpoint, or intersection, but all three at this location are coincident, so it doesn't matter which one appears. However, be careful not to click, because we don't want to start drawing at this point. All we want to do is acquire the object snap tracking line, which appears when you move the cursor to the left. If it doesn't appear, go back and try to reacquire it. You see, each time I do that, I either get it or I don't. I'll reacquire it now. This dashed green line works just like it does in polar tracking. It allows you to snap along that direction. So I can draw a line that is lined up with that snap point. I'll select that line and delete it. You can also intersect object snap tracking lines, and I'll show you what I mean next. Draw a line, and without clicking, move the cursor over here and acquire this tracking point, and then move the cursor to the left. Then carefully come up here and acquire this point as a tracking point and move the cursor down. And as you come down here, you're going to find a point where those two dashed green lines intersect. I can click here to start drawing my line exactly from that point. This is an alternative to drawing temporary construction geometry or using the from object snap. Object snap tracking can get a little confusing though if you leave it on. If I come in here and start moving around, you're going to get all kinds of weird green lines appearing here. So I tend to only use object snap tracking when I need it, and then I'll turn it off when I'm done. You can press the F11 key to toggle this mode on and off. In the next video, we'll take a look at user coordinate systems. By default, AutoCAD uses what is called the World Coordinate System, or WCS for short. It's possible to create your own User Coordinate System, or UCS, that has a different origin point, or is rotated with respect to the WCS. You will create a UCS and draw objects using it in this video. Open the mechanical sample file in the Chapter 6 folder. Let's turn on the User Coordinate System icon by typing UCS icon. Enter, and then choose On. This represents the X and Y axes, and this box is located at the origin point of the grid. If you click this icon, you can then move the UCS to a new location. I can move this down here, and what I've done is I have moved the origin point, and I've created a UCS at the same time. Notice, though, that there's no longer a box around that point. That means I'm dealing with a user coordinate system. The world coordinate system was the initial one. So now we're working with something that's a little bit different. Now, so at this point, it doesn't really matter. Why would you care if you move the origin point? Where this comes in handy is when you start to rotate the UCS. And you can do that with these grips here. I'll click this grip and I can rotate that. And watch what happens to the cursor. It also rotates. I'll press Escape. Now, if I draw a line and turn on ortho, you will see that the line is working with this new coordinate system's orientation. And so this can come in handy if you're trying to draw something that's at an angle. So let me just erase these. Notice that you cannot erase the UCS. It's a drawing aid that remains on the screen. You can turn it off, but you can't get rid of it. I could type UCS icon off, but I would still have the benefit of this rotated coordinate system. Now over here, let's say I want to draw in this little area and make it bigger. I'm going to move the UCS over there, and I will snap its origin point right there on the corner. And then I'm going to grab one of these grips and rotate it around like so. Now my coordinate system lines up with this geometry. At this point, I'd like to stretch this part out so I have a larger surface that's at this angle. If I use stretch, the selection window is still in the WCS system. So I have to be really careful about how I select that. And I can just do it here. I can just select those objects, enter, and then I'll click a point here, turn on ortho, and drag that over. So I have now a larger surface to work with, and it has maintained the same angle, a 45-degree angle going down with respect to the horizon. You can also rotate the user coordinate system using the keyboard. You can type UCS, enter, and then you can type in the axis that you want to rotate around. In this case, I want to rotate around the Z-axis. That's an axis that comes out of the screen, perpendicular to the XY plane. I'll rotate around the Z-axis 45 degrees, and that rotates it back so that it's horizontal. Another way you can work is by orienting the UCS relative to a selected object. So for example, let's say that we draw a rectangle over here, and then we rotate that at some arbitrary angle. I'm just going to rotate it about like that. Now I want to work with that, and I want to draw using that as my reference. So I'm going to type UCS, enter, and then I'll use the object option right here. Click on that, and then click on the object. And automatically the UCS will move its origin point and rotate itself to suit that object. Now I could go ahead and draw a line using ortho that is relative to that geometry. So in this way, I can detail something that's at an angle. You can also view that information as if it was in front of you, like a floor plan, like you're going to rotate the paper so that you're looking with the x-axis horizontal and the y-axis vertical. And you can do that with the plan command. Type plan, enter, and then you're going to use the current UCS, which is the default option. So just press enter again. It's like rotating the sheet of paper, if you will. So now we're looking at it like a floor plan, like we're looking at the sheet of paper with respect to our UCS. So if we had an extensive amount of work to do in this geometry, we could do it. And then when we're done with that, we could go back to the initial orientation by resetting the user coordinate system first, UCS, enter. And I'd like to reset that back to the world coordinate system. So I'll choose this world option. It's actually the default option. So all I have to do is press enter. And now the UCS is gone and we're back to the WCS. Now it's very subtle, but I can tell that this is the WCS because there's a little box right here. Now I want to rotate the drawing, so I'm looking at it orthogonally, and I can do that with the plan command again. Plan, enter, and I could either go to the current UCS or I can choose the world option. They're equivalent in this case, world. And now I'm back to where I was. So there you've seen some interesting ways to reorient your coordinate system to suit the type of work that you're doing. Of course, in 3D, you can rotate the UCS at any angle on any surface, and this becomes invaluable when you're doing 3D modeling. But it's also quite helpful when you're doing 2D drafting, when you're trying to draw objects that are at an angle. In this video, we will be gaining some practice with this mechanical drawing project. We'll be drawing this missing view. Let's begin by turning on some running object snaps. Click the arrow and turn on endpoint, midpoint, center, quadrant, intersection, and perpendicular. Let's also turn on object snap tracking and ortho and leave dynamic input on. Draw a line and acquire a tracking point from this endpoint. Acquire another tracking point over here and move back and find their intersection. Then acquire a point like this, and then come over here and acquire a point up here, and so on. In this way, you can sketch in the overall form of what the front view must look like. I notice over here in the right view that this part of the object goes down, so I need to account for that. I'll draw another line and acquire this point and this one and find their intersection. Now, judging from this area, it looks like this portion spans the whole object. So I can copy line here over there, and then I'll draw in another line across the bottom. Now it looks like this is a kind of tower that sticks up, judging from this diagram on the right. So I need to acquire a point, and I notice there's a gap here that we should fix later. I'll draw this down, and In this case, because I didn't use tracking, I need to then trim off this piece. I'd like to fix that by using fillet. I'll type F, enter. I'll click these two lines to join them together. And then I will go ahead and copy these two lines from here to here. It looks like there's a base plate here that we need to account for. So let's draw a line over like that. And then these should be cut off. So we will trim, press enter to accept all edges as boundaries, and then just click those three segments to get rid of them. Now, it doesn't look like this is quite correct over here. Let me fillet this line and this line, and I join them together. Again, here and here. So that's starting to look better. I notice that there's this strange dashed line here. I think that's a weld, and it's probably similar to the curvature of this one, and it's going to be right over here. So I'm going to mirror this object about a mirror line, which is, let's just approximate it right about here. And that didn't quite hit it, but it's close. I'll move this over now, M, enter. I'll grab it from the endpoint and move it perpendicular there. That looks good. Okay, what about this object? What is that? It's a hole that goes through this plate. So I'm going to draw a line, and I will acquire a tracking point from this quadrant, and I will draw it down here. And again over here, like so. Now this is the hole in the right view. So the hole is going to be radially symmetric. It's going to be the same over here as it is over here. So I should be able to copy all of this over, grabbing it from this endpoint and placing it there. It fits. So we can go ahead and erase these two lines. So we're on the right track. Okay, what's left? We have this curve. We could probably represent that with a line like that to show where that radius transition ends. And then again over here. Now we have a circle on the side, and that's going to cut through this plate on the side. So we need to represent that with a dashed line. I'm going to draw a line acquiring from this quadrant like that, and from over here like so. Now these two lines, this one and this one, are hidden in this particular view. So they need a different line type. I'll change that right here on the Properties panel to Hidden, and then press Escape. And it looks from up here like this is a hole that goes through both sides. So I need to copy that over here like this. There's also a hole in the back, and it looks a lot like it's the same diameter as this hole. Let's just check that out. I'm going to copy this hole from its quadrant point, turn off ortho by pressing F8, and I'm going to put it right there on the midpoint. And sure enough, it's right on the right size. The problem is it doesn't show me in this diagram where that is. I'm going to guess that it's at the same height. I'm going to move this down and acquire a tracking point there and put it right there. Now I could improve this diagram by showing where that hole would be in the side. So I'm going to copy these two lines here and put them over here. Now that's a thicker plate, so I have to extend these lines to meet this one. So I can use the extend command, or I could just use trim, press enter, and then hold down shift. And that inverts trim to make it work just like extend. So there we have it. Now, what are we missing? I think down here we have another hole, and that's not shown up here either. Again, I'm going to have to kind of design the part because not enough information is given. So I'm going to copy this circle, enter, from its lower quadrant, and I want to acquire a tracking point here and place it right there. Again, we should improve this diagram with this information of where this hole goes, and we'll do that up here. I'll copy these two lines and make them perpendicular there, and it looks like I need to extend them just a little bit. This time I'll explicitly use extend. Press enter to select all objects as potential boundaries, and then click, click, enter. So let's see. It's coming together. I don't think there are any problems. Maybe I could trim away this little bit here. I could do that either with trim or with fillet 0. Let's take the latter approach. F, enter. The radius is 0. You can read that right there. And I'll click this arc and this line. That looks a little cleaner. So there you have it, the front view of this mechanical part. This should give you some practice and challenge you to solve problems as you encounter them. In this video, we will begin a drawing project that will put a lot of the things you've learned in this course so far to use. Open the floor plan sample file in the Chapter 6 folder and you'll see that it's blank. I've already set the units to architectural and I created a layer which we'll get to later. Let's go ahead and attach an image of a sketch I made on a piece of paper. Type IM for image and press enter. This opens the external references palette. Up here, open this menu. Rather than clicking on the icon, click on the arrow, and then choose Attach Image, and select this JPEG. Click Open, and then set Relative Path, and uncheck these three boxes so that the image is attached at the origin point with a scale of 1, and with a rotation angle of 0. So I made this rough sketch of a simple architectural plan. I took a picture of it with my phone and emailed it to myself. So you can do this sort of thing to sketch your own apartment or house where you're living, and it will give you some good practice to put the skills that you've learned in AutoCAD to use. So now let's go ahead and close this palette, and let's measure a distance here. I'll click the measure tool, and then I'll click 2 points here and over here. Now that measures about 1/4 inch, and we need it to be a lot bigger. So our first task is to scale up the image. What we should do is select the largest dimension and scale to that. That will give us the best accuracy. So we have 18 feet, 3.5 inches here. I'd like to change the current layer, and you do that up here on this layer drop-down. Click on the word A wall for architectural wall. That sets this layer current, and that means that when I draw now, anything I draw will be on this red layer. So let's draw our first line from about here at the arrowhead. Make sure ortho is on so the line is horizontal, and draw it right to this point. Enter. So this line has got to become 18 feet 3.5 inches. And right now it's about 1/4 of an inch long, so we have to scale it up a lot. So next step, use the scale command. Select the red line that you've just drawn and the image by selecting its outer frame. Enter. Specify base point for the scale. That will be here on the left end point of the line. Specify scale factor. Now I have no idea what the number would be to get from 1/4 inch up to 18 feet 3.5 inches. So I'm going to let AutoCAD calculate that for me. To do that, we need to click the reference option. It says specify reference length. That would be this red line's length. So I'll click this endpoint and the other endpoint. Now it says specify new length. Now I just need to type in the new length that I want it to be. In this case, 18 feet 3.5 inches. So I'll type 18 feet. That's the apostrophe symbol next to the enter key. 3.5. Now I can type 3, but I don't want to use the space key to separate the whole inches from the fractional part of the inches, because if I did, it would be the same as pressing enter, and then the line would just be 18 foot 3. Instead, what we need to do is use a delimiter to separate the whole inches from the fractional inches. And that delimiter is the dash key. So type dash. And then ½ inch is represented like this, 1/2. So that reads 18 feet 3½ inches. It's not necessary to use the inch symbol. You can, but it really isn't done because in imperial units, the units are inches already. So you don't need to specify that in particular. So go ahead and after you've typed that in, press enter, and everything got scaled up. Now we need to zoom out and see the whole drawing again. Press Z enter for zoom, E enter for extents. And now we're looking at basically the same thing, but everything is much larger. So let's measure this line from this endpoint to the other endpoint, and now it's exactly correct. In the next video, we'll begin drawing the walls. In this video, we will begin drawing the walls from this floor plan sketch. We've already scaled the sketch up, so it's approximately at the right scale. Now let's go ahead and begin drawing the walls. Click Line, and let's start down here in the lower left corner. I'll draw a line all the way over here. I don't really know how far that's going to be yet, so I'll just draw it in approximately like that. I notice down here it says 8-inch thick, typical. So I can offset this line 8 inches. So click offset, type 8, enter. And then select the red line and click below it to offset that down. And then press enter. I can pan. We can see that maybe a little better. Now no angles are given here. This looks to me like it's part of an octagon. So let's draw in an octagon with a 4-foot edge, and we'll put that in there. I'm going to pan over to the side a little bit and use the polygon tool. The number of sides is 8. I don't know where the center would be, but I can use the edge option. And then I will click a point right here, and I'll move the cursor upward and type 4 feet, enter. Now I'm going to move this over. So I'll type M, enter, select the octagon, enter, grab it from this endpoint, and attach it here. Now evidently that's too small. Let's measure this and make sure we haven't gone astray. Measure from here to here, and it says 4 feet. So it's probably correct, but the sketch must be distorted. And that's typical for hand-drawn sketches. When I drew this, I sketched in all of the walls first, and then later I put in dimensions. So I have no real way of knowing when I was sketching how big to make things. So we're going to have this big mismatch between the accurate CAD drawing and the sketch. So I recommend that we move all of these lines that we've drawn over here, and then we'll just have to refer back and forth to the sketch and what we're doing over here. So this is a polyline, and I want to explode it so I can get rid of parts of the octagon. Choose explode, select it, and press enter. Then erase these parts. There's also a part down here that's on top of that red line. Press enter. Okay, let's continue drawing. Line, enter, L, enter. I'll click this here, and this is supposed to go up. It looks like a total of 9'5", so I'll type 9'5", enter. And then it's going to go over to the right, 18 foot 3½, 18 foot 3½. And then we have a closet. We don't really know how big it is. And we have to do a little bit of detective work here to figure that out, because down here, it looks like there's a matching closet, and it has a dimension, 2 foot 2½. So let's draw in another line here, down, and then we will offset that line by typing O, enter. Then I'll type in that distance, 2 foot 2-1/2. And then I'll click the line and then click on the right side. So that gives us the closet width. And then I notice right here, it says 5-inch thick typical for the interior walls. So we can make some assumptions about the wall here. This is going to be offset 5 inches. So offset 5, enter. And then I'll click this line and then click on the right side to offset it. We probably also need to offset the closet inward like that. Let's go around and offset some of the exterior walls while we're at it. O, enter, 8, enter. The exterior walls are thicker. I'll go ahead and offset these one at a time. And now I would like to join them together. So I'll use the fillet command, F, enter, with a 0 radius. You can see that right here. So I'm just going to click each pair of lines, press enter to repeat the command, and keep going, joining them together in corners. Okay, now we have an interior wall here, and it looks like it probably comes from this edge point here. So let's go ahead and draw that in. Line, cross. It goes all the way probably to here. I don't know if it goes to the midpoint, but it certainly goes perpendicular. So I'm going to click that snap. And then offset, O, enter, 5, enter. I'll offset that up. So we're starting to block in the rooms. Now down here it says 6 feet. So this closet is 6 feet up. I'll use offset, O, enter, 6 feet, enter. Click this line and then click above it. And then that wall has some thickness, so I need to offset that 5 inches down. And then I imagine that this closet over here is the same. So I could offset it again, or to save a little time perhaps, I can mirror it. I'll use the mirror tool here. I'll select these two and mirror them about the midpoint of this line, like that. Now I need to clean things up. It's starting to get confusing, so I'll use the trim command, and then I will just press enter to select all objects as potential cutting edges. And then I'm going to make a crossing selection here, and here, 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 and so on. So I can just get rid of the parts that I know don't belong. We're left with some little bits that we need to get rid of. I'll make a window selection around these 2 lines and then press the delete key. Up here I'll type F for fillet, and I'll fillet these together like so. I'm going to pan over a bit more and see if we can get in a few more walls. Type offset 8'7", enter. Click this line and click on the right. Enter to end offset, enter to repeat offset. Type 5, enter for the thickness of the wall. Select the wall and click on the right side, like that. Enter to end the command. Now I'd like this line to go over here, so I'm just going to select it without using a command. Click its grip and move that over here. Some arbitrary length. I don't know how far it is yet. Press escape to deselect. Then offset, O, enter, 13'1", enter. Select that line and click below it, enter. Now that looks like it's right on, so at least the dimensions look to be somewhat accurate. I'll type offset, enter, 5, enter, and we'll just offset that line down. I'm going to zoom in here and see. Now actually they're off a little bit. This is probably the inaccuracy of the dimensions. So to clean things up, I think what I'll do is move these 2 lines that I just offset. I'm going to move them from this intersection point up to go perpendicular there, so everything is lined up. That's going to be better. Now I'll type TR for trim, select this specific cutting edge, press enter, and then trim off these 2 lines. Okay, now we just need to draw in the kitchen and complete the outline of the building. I'll type O, enter for offset, 9 feet, enter, and I'll offset this to the right. Enter to complete the command, enter to repeat, type 8, enter for the outside wall, and offset that on the right. Now I'll do some filleting, F, enter, press enter to repeat the command, every time you need it. It's more efficient to do a bunch of filleting all together. Now I'll trim, TR, enter, select this cutting edge, enter, and then select these two lines to get rid of them, enter. So we've blocked in the walls in general, and in the next video we'll cut door and window openings and continue fleshing out this floor plan. We're going to cut door openings and draw in the windows in this video. Open floor plan 3. I'll zoom in here and let's focus on the kitchen area. There's an opening over here and it doesn't say how big it is, but it looks large. It looks like it's similar to this door. Let's assume it's 3 feet. To locate that, we're going to have to put in the counter, put in 1 foot of space, and then 3 foot opening. So let's just pan over here and offset, O, enter, 24. Likewise, I could just type 2 feet, but 24 will do. Enter, and then I'll select this line and click below it to offset that down. That will be the counter in the kitchen. Then trim, select this edge, enter, and click this part to get rid of it. Enter to complete the command. Then O, enter for offset, 1 foot, enter, offset this line down, and then again, enter, enter, 3 feet, enter, click this line and then click below it, and then enter, enter, 9, enter, click this line and click below it. Now, I will use the move command, M for move. I'll select these 3 lines, and I'll just move them over an arbitrary length. Then I'll use TR trim, press enter again to select all, make a crossing selection through this opening, and then trim away these pieces that don't belong. Here I want to get rid of this piece and this piece. Now, this counter is probably as deep as this counter, so we will offset it 24 inches, or in this case I'll just type 2 feet, enter. I'll offset that to the right. And then F, enter for fillet. Click these 2 lines to make the counter. Down here on the bottom, we have a 2 foot counter also, or cabinets. O, enter. 2 feet is still the distance that's set there, so I can just press enter to accept it. And then I'll click this line and click above. Okay. So we have some cabinet lines. Trim, TR, enter. Select this wall, enter, and then click this piece to get rid of it. Okay, we'll come in later and we'll draw in the detail, but now I'd like to put in this 3 foot door. So I will draw a line, L, enter, from here to there, and then I'm going to move this line up, M, enter, select the line, and click a base point at some arbitrary location and move it up. Let's say I'm going to move it up maybe 5 inches. So we have a gap between the door and the cabinet. Then offset, O, enter. That's a 3 foot door in the sketch, so 3 foot. Enter, click the line and click above. Then trim these 2 bits so we have a door opening. Now let's pan over a bit and take a look at what we have to do next. It looks like there's a door opening here for a 2'6" wide door into the washroom. So offset 5 inches, offset 2'6", trim. Up here, we have a 3 foot door that appears to be centered. So I'm going to find that center by drawing a temporary line here across the gap to the other side. Then I'll draw a line up from its midpoint. Then I will offset that half of 3 feet, that's 18 inches. I'll offset it on both sides. Then trim. And then select these 2 lines which are temporary and press the delete key to get rid of them. Let's see, over here we have a pair of doors surrounding this wall. They're 2'6". So I will draw my first line here. To determine that, let me see how much space I have to work with. I'm going to measure this distance. It's 3 feet. Okay. So we could offset this line over 3 inches. Offset 3 inches. And then I will move that over and then trim. And then offset 2'6" going up. And then trim. And then I need to do the same on the other side. But to clean that up first, I will do some more trimming. And then here, that needs to be trimmed also. And what do we have down here? We have some more trimming to do. So ideally, I'd like to get this door opening mirrored around the other side. In order to do that, I need to find the mirror axis. And that will be a horizontal line centered on this wall. So to find that, I'm going to draw a short line segment right here. And then I will use the mirror command and mirror these 2 little segments. And the mirror line will start here at the midpoint of this little segment, and it will go over to the right. Then I should be able to trim these pieces away and get rid of that segment. Looks like we have some extra space in this room in comparison to the other one. Okay, now do we have any more door openings? There is one more right here, and it's a double 3-foot set of doors, I think more or less in the middle of that wall. So I'm going to draw a line from the midpoint to the other midpoint, and then offset with 3 foot as the distance on both sides. And then trim and erase. Over here, trim, TR, enter, and click. So I believe we have all the door openings. And what we need to do next is put in the windows. The windows aren't cut into the wall, but they're going to be shown in the following way. I will draw a line here at the midpoint over, and then I'm going to offset that 18 inches above and below so that we have a 3-foot window. That's what the sketch calls for after all. Over here it says 3 feet. So I imagine that these are also 3-foot windows, and this one is too. So we're going to have to get these windows in. I'm going to draw a line here to represent the window. Then I'm going to copy this whole assembly over. And now I want to rotate it 45 degrees to match the angle of this wall. Then I will move this over like that. Then mirror this window from this point horizontally. Let's get rid of these middle pieces. And now we have the representation for windows. Finally, there's going to be a window in this room, so I'm going to copy this window up here somewhere to start with, and then I'm going to move it down. To find that point, I'm going to draw a temporary line here across. Then I can move the window and the temporary line from this intersection point to the midpoint of the wall. Then I can select that and press delete to get rid of it. So there we have it. I've created all the door openings and drawn the windows. In the next video, we will start to add the doors and some of the details to the plan. In this video, we will draw in the doors and start on some of the details to the floor plan. Open the Floor Plan 4 sample file in the Chapter 6 folder. Let's work on these doors here, which are double 3-foot doors. It says they're 1.5 inches thick, typical. So let's go over here, zoom in, and draw the first door with the rectangle tool. The X distance will be the door thickness, 1.5. The Y distance will be 3 feet. So I'll type comma to move me to the Y coordinate, and then 3 feet, enter. Now I'd like to draw an arc that represents the door swing. I'll do that with center, start, end. There's the center. The start will be 3 feet over, so I'll type in 3 feet. And the end will be right here. Now I can use the mirror command, select those two objects, enter. I will mirror it from this endpoint, and then I'll click down below and press enter. Now over here we have a door that's also 3 feet wide. I'm going to copy this door over here and then rotate it, RO enter, and then rotate it around and then move it into position like that. We have another 3-foot door over here, and we can copy this door again. I'll toggle off ortho temporarily by pressing F8. And then I will rotate this, and I'll toggle ortho back on by pressing F8, and then move this over like so. Now over here we have 3 doors which are 2'6". So let's go ahead and draw in the next door right here. I'll start here, and I'd like the door to go over like this. So the x coordinate is going to be a negative value because I want to go to the left relative to the first point. So I'll type in minus 2'6", comma 1.5, enter. Now for the arc, I'll type A for arc, enter, and I'm going to press the down arrow on the keyboard to access this option center. I'll click center, and then I'll click the center point right here. The start point will be up here, and the end point will be right there. Then mirror these 2 objects, enter, from the midpoint of this line horizontally over, like that. Over here, the door is going to be here, and the swing will be like that. So it looks like this door would be the right one to copy. I'll copy it, turn off ortho, rotate it, turn ortho back on, move into position. So we've completed the doors. Now we'll work on the closet doors. Those are a bit trickier because they're bifold doors. Let's come down here and let's just figure that out. We have a little flexibility in doing so. Now, I don't think the doors would be right here. There'd be a bit of wall that would stick in a ways. So let's just offset maybe 3 inches. We'll offset this down 3 inches, and we'll offset this up 3 inches. And then I'll go ahead and move this line over horizontally. And then I'll use trim to cut that open like that. Now here I want to use trim a little bit more carefully. I'll use trim, and I will explicitly select these 2 boundary edges, press enter, and then I'll cut those 2 lines off. Finally, I'll repeat trim and just get rid of that little segment there. There's one more here too. And another one over here. Can we clean anything else up? Yeah, it looks like there's one up here we could trim. And I think that's it. So we'll zoom in here. Now the bifold doors, there's 2 pairs of them, and they're going to meet in the middle. So I'll draw a line across here, and then I'll draw a line like that. Then I will trim off this line so that we have a single line representing a pair of bifold doors. Then I'll do that same kind of trick again, drawing a line, trimming it off, and that would be the distance for a single bifold door. Now I want to draw in a door, and I'm just going to offset that 1 inch. So this is rather thin. Actually, maybe that's a bit too lightweight. Let's do it 1.5 inches. I'll move that over 1/2 inch, 0.5, enter. Now I will draw a rectangle from here to here, and then erase all of those objects, but remove by typing R, enter, L, enter. So in this way, I'm erasing all of that, but I'm removing the last object that I created from the selection set, so that all that will be left is this rectangle. Now I will rotate it from this hinge point right here, turn off ortho, and I'm just going to rotate at some arbitrary angle about like that. Then I'll copy it down and move this so that it lines up with that, and then rotate it from this hinge point in a ways. Now, if that was to close, it would fill up half of this space. So now I can mirror these two from the midpoint here over. And then we should be able to save a lot of time just by copying that whole assembly up above. So I'm going to copy all of that stuff from here up to right here. Let me just zoom in there and see if I got that. It looks correct. Now I can just erase these two lines. And it works pretty well. We're missing a couple of segments. Okay, so I've drawn all the doors and detailed the bifold doors in the process. In the next video, we'll add in the remaining pieces of this floor plan. In this video, we will fill in the remaining details to the floor plan, including the bathroom fixtures and kitchen appliances. Let's start by taking a look at the washroom here. We have a tub, toilet, a sink, and maybe a towel rack or something over here. So let's try to create that over here in this small washroom space. No dimensions were given, so we can just assume some standards. I'm going to offset by typing O enter, a set distance representing the width of the bathtub. I'm going to guess that that might be 2'6". And I'll just offset that to the right. Now, to make a nice curved tub, I can use a rounded rectangle. So I will use the rectangle tool. And before I draw the rectangle, I will set a fillet radius. So click this option. And let's say that there's maybe a 2 or 3 inch radius there. I'll say 3 inch. And then I'll draw a rectangle like that. Now it's a bit too large. So if I scale that down, it would be better. I'll use the scale command right here. Select the rectangle. And now I want to scale it from the middle, but I don't have anything to snap to there. I'll turn on object snap tracking if it's not already on, and acquire a tracking point there, acquiring a tracking point there, and then click at their intersection. Now I want to make it smaller, and it's kind of hard to do that interactively because it's a little bit too sensitive. So I'm going to type in a scale factor. Let's try 0.8 to make it 80% as large. That looks pretty good. I'm going to zoom in here, click on this polyline, and convert this to an arc. So we have a more generous curve in the back. However, I think this looks a little weird with this arc and then another arc. So what I'd like to do is explode the polyline and then erase these two arcs. Then I will type blend and then create blend curves between the arc and the line, and again over here. That looks better. Okay, now we need a toilet, and for that I will draw another rounded rectangle representing the tank. I think maybe the radius is too large, however, so cancel. Do that again. Set the fillet radius to 2 inches, and then draw in a tank. Then we need the bowl, so we will use an ellipse, something like that. Move that up a ways, use ortho, and trim off the extra bit. And then move those two objects perpendicular to the wall. Up here we need a sink, and a rounded rectangle will work pretty well for that too. Perhaps we need another one inside of that, so perhaps we could offset it. Offset 1 inch inside. That looks okay. Maybe I would scale this down a bit or scale the other one up. What if we offset this outward 1 inch and then deleted this middle bit? That looks okay. Now I will stretch this, just the top of that rectangle, down. And then I'll put in a circle here, and I'll specify its diameter is 2 inches. And then I will move that up like that. Now let's say this is a separate hot and cold, and we want 2 of them. I will explode this rounded rectangle and then use the divide command and divide this line into 3 parts. Now I need to see the dots, so I'll type DDP type, change this to a point style that's more visible, and then move the circle from its center over here, and I'm going to acquire a node snap off of the point like that. Then I can move this up a bit and then mirror the circle around the middle. I can then erase these points and move this whole sink up against the wall. Over here for a towel rack, we can just show that with a rounded rectangle. Perhaps we'll set the fillet radius to be larger. We'll say it's 3 inches, and we'll make it like that. Then move this down, and then trim that off. Perhaps move this over also. Okay, the washroom looks done. How about in the kitchen? We need a sink, a range, and a refrigerator. Okay, over here, for the sink, a rounded rectangle will work well. I'm going to turn off Object Snap temporarily by pressing the F3 key so I don't inadvertently snap to the endpoint of the counter. I will draw in a sink approximately like so, and I'll move it down like that. I'm going to come in here and move this so that the sink maybe is a little closer to the edge of the counter. And then I'll draw a circle, CI for circle, and I'll turn on Object Snap by pressing the F3 key. I'll draw a circle here with a diameter of 2, and I'll just move that over a little bit, like that. Maybe this is a double bowl sink. If so, I could draw a line across like that to represent it. Now you can be as detailed as you want. You could go to the manufacturer's website and perhaps download a drawing of a sink, or you can just represent it more abstractly like I've done here. It's up to you how much detail you want to put into it. For the refrigerator, it's going to fit in this area, and I'd like to draw a rectangle, this time without any rounded corners. So I'll choose Fillet, 0, Enter, and I'm just going to draw it here in the middle of the kitchen, and I'll type at 30, 30 to specify a 30-inch square box. Then I will move this over against the wall, and then no appliance is perfectly against the wall. It's going to be out a bit, so I'll move it back an inch, and then I will move it down here against this counter, and then move it again up an inch. And then the counter here, I want the counter to go from there to there, and then I want to move that line up, let's say 2 inches to give the refrigerator a little breathing room, and then I will fillet these 2 lines together. So now we have a more realistic looking refrigerator. Now I will draw a line from here, turn off ortho, and I'll draw it at some arbitrary angle like this, but I want it to be 30 inches long, so I'll just type 30, enter. Now an arc is needed, so I'll just type A for arc, press the down arrow and click center, choose the center point, and I'll start the arc here and end it there. So that represents the swing of the refrigerator door. Finally, we need to create a range, and that is easily done with a few circles. Draw a circle here, and let's say the diameter is D, enter, 8, enter. Let's move that, and then copy it. Turn on ortho. So there we have it. I think I've completed the entire project. The last thing we can do is detach the image. Go and type IM for image to reopen the external references palette, and then right-click on the image sketch and choose detach. Close the palette, and congratulations, you've completed a challenging project. I recommend that you sketch your own house or apartment and draw it in the computer. This will give you invaluable practice with AutoCAD because you'll run into lots of different problems that you'll have to solve, and it will really test the knowledge that you're learning. And when you work through those challenges, you will really earn some new skills. And good luck and have fun. In this video, we're going to explore the hatch command. Open the mechanical sample file in the Chapter 8 folder and zoom into the top view. Make sure that you zoom in so that the entire top view is visible on the screen. I need to zoom out a bit. I'll type Z enter and then press enter again for the real-time option, and then I'll drag downward so that I can see the entire part. I'll also pan by dragging the mouse wheel and then press escape. The reason I have to be careful about this is the hatch command uses a ray casting algorithm to actually analyze what's on the screen. So if I'm trying to hatch this upper rectangle and part of it is sticking off the screen like that, it might not be able to find the boundary. So I'm going to make sure that it's all on the screen before I use the hatch command. Now, let's go up here to the draw panel and open up this flyout menu and select hatch. Now the cursor should say pick internal point. If it doesn't, that's because someone has used select objects previously. The hatch command is sticky, so that means if you use select objects mode, it's going to stay that way until you change it next time. So if your cursor says select objects, you have to go over here and click pick points. If it says pick internal point, don't do anything. You're ready to go. Now, move the cursor over the part, and you may or may not see a preview image like this. In some areas, it won't show a preview like right here because it's having more difficulty determining that boundary. It will have more luck in simpler areas like this one. Up here, it can't find it. It's not having much luck. Down here, it's okay. Now, this really is two separate regions, but AutoCAD thinks it's one. Let's zoom in there. Move the cursor around. Sometimes you can convince it to separate that into two pieces. No such luck this time. It really is random. The hatch pattern doesn't always work consistently, so you have to kind of experiment with it. Now, I'd like to hatch this area, and I don't see a preview, but I'm going to hope that AutoCAD finds the area and just click. In this case, it worked. Sometimes it won't, and you'll get an error message, and you just have to zoom in a little more and try again. Like if I go over here and click, it gives me that error message. A closed boundary could not be determined. And there's a reason for that, and I can actually see it right here on the screen. There's a tiny gap right there, and it's not able to find that boundary because the ray casting algorithm escapes out through that hole, and it can't recognize this as a boundary. But let's not worry about that right now. Let's focus on this single hatch pattern that we are creating. So right now it's coming in with the last selected pattern. In this case, it's the ANSI 31 pattern. There are many patterns to choose from in this list, and I recommend that instead of clicking on these arrows, you click on this little arrow to expand the selection area. There are several different standards here that have emerged over the years AutoCAD's been in existence. There's the ANSI pattern. There are these AR patterns for architecture. There are also patterns that are just single words like brick, cork, clay. There's also gradient patterns, and if you go down further, you'll find the ISO standard patterns. So there's sort of sets of patterns that you can choose from, and they appear in different scales. So this one here is too dense, evidently, at a scale of 1. Here's where you set the scale. Let's change that to a larger number. Let's try 5. I'll type 5 and press Tab to have that take effect. That looks better. You can also interactively change the angle by dragging this over, and you can optionally make it more transparent. And this is nice so that your hatch patterns don't really visually dominate your drawing, but they appear more in the background. This will still give us a sense of materiality to the object. This is steel, and that's all we want. We don't want to have this compete visually with the dimensions. I'll make it a little brighter so you can see it at least while we're designing it. Now over here you can change the color specifically to something else. I could make it blue. And it also has an optional background color. What if we had an orange background with blue lines on top of that? These are all possibilities. I'm going to clear that out and say no background, none. We'll also clear this out and say assign the color by the layer. Let's open the properties slide out. Right here we can choose a different layer. We're using the current layer, which is layer part right now. I'd like to open that up and choose layer hatch. So now it assumes the color of layer hatch, which is yellow. Another thing you can do with hatch patterns is set the origin point. Click this button and zoom in on a likely origin point, like this corner. Snap to that point, and the hatch pattern will line up with it. This is very helpful when you're making tile patterns, for example. You want them to line up. Let's expand the options slide out. And over here, we have different ways to detect islands. Let's open that up. Normal island detection works like this, where the point that we clicked is hatched, and then the next boundary within that is not hatched, and then the one within that is hatched again. And you can kind of tell that from this icon. Hatch, no hatch, hatch. This one is just the outer area. This one is ignore all the islands and just hatch everything. So I think in this case, I just want to have the outer island detection on because I don't want to hatch the whole. Gap tolerance is helpful when you want to bridge over gaps like you see down here. So if I increase the gap tolerance to some small value, and I don't really know what the units are here, but I'm just going to increase that a little bit, and then I'll click down here, and we still have a problem. Continue hatching this area, and maybe increase the gap tolerance more, and then click down here. No such luck. We'll have to try another approach. In the next video, I'll show you how to create a hatch pattern by selecting objects, and that's a more robust method of creating boundaries. In this video, we will create a hatch pattern by selecting objects. You can use this method when you're having problems creating a hatch boundary. In the last video, I had a problem hatching this little area here because of this gap that appears in the lower corner. Let's see if we can hatch that by selecting the edges of the area in question. So open the mechanical sample file in the Chapter 8 folder to follow along, and then click Hatch on the Draw panel. Click Select so that you can go into this Select Boundary Objects mode and select these objects with a window. Notice that it's only selecting those two arcs, the top line and the bottom line. These lines actually extend above and beyond the area that I'm interested in. So this method isn't working yet. It's hatching all the way up here, and I don't want that. So I'm going to press Escape. Then select the hatch pattern and press the Delete key to get rid of it. What we first need to do is create a series of objects supporting this notion of a boundary. And this object goes beyond our boundary. So let's break it. We'll go to the Modify slide out and click Break at Point. And then select this line and snap to this end point of the arc. That breaks it into two pieces. And we'll do that again on the other side. Now I can click right there. Okay, let's just see by moving the cursor over the line. It looks good. So now let's try to hatch it. Click Hatch. Make a window around all of these objects. And it works, even though there's a gap. So this method, as I said, is more robust. It works when picking points does not. So I wanted to point that out to you. We can then continue hatching. This time I'll choose Pick Points. And over here, I'm not getting the success that I want either. It's getting the whole thing. But notice that when I zoom in, it suddenly was able to find the boundary. Here at this zoom level, it doesn't. You see how the hatch pattern is sort of temperamental? If you were to assign a personality to it, it's a bit temperamental. So I'll click right here, and it worked this time. So you may have different results. So I recommend that if you have troubles, go ahead and use Select Objects and make sure that you have objects first that can describe a closed boundary. So there you have it, all the different ways you can select hatch pattern boundaries. In this video, we will experiment with the gradient command. Open the plumbing sample file in the Chapter 8 folder and zoom in. This is actually the water system in my house. I have a wood stove that heats the water and it goes up here in the range boiler. I have a panel on the roof that heats the water also through a heat exchanger. And the water in the range boiler is a source of preheated water that goes into the electric water heater. So to make this diagram stand out more, I'd like to insert gradients into these pieces of equipment in these tanks. And that will represent the temperature gradient that goes from cold to hot. In the range boiler and in the electric hot water heater, the colder water is at the bottom and the hotter water is at the top. So we can visually depict that using a gradient. You'll find the gradient tool up here underneath the hatch command. It's actually the hatch command itself, but it's customized so that it automatically selects the first gradient pattern here. If you open this up, you'll see that it's actually the hatch command. You have access to all the regular hatches as well. But you can type the word gradient as a separate command and it will automatically select the first one here. There's a linear gradient and two cylindrical gradients, which are really linear gradients that are mirrored. There's also spherical and inverted spherical. There's a hemisphere and an inverted hemisphere, and a curved and inverted curve. So there's really just those types to choose from. It's pretty basic. I'll go with linear because in this example, I just want to show that continuous transition from cold to hot. Click Pick Points and click a point inside the electric hot water heater. And then let's go up here and change the angle. You can drag that slider over and we'll go all the way over to 90 degrees. So I could try to get that by dragging, which is a little bit tricky. Or I could just type a number in here. Now, it looks like the cold area would be blue at the bottom. That's already set. But the hot area should be red. Let's change yellow to red. If you don't like the red, you can go in here and choose one of these shaded reds or tinted reds. Or you can go to more colors and go to true color, where you can choose any one of millions of colors here in this color ramp. I'm satisfied with the basic red color though, so I'm just going to leave it like that. And I'll click Close Hatch Creation. Now the next time I make a hatch or gradient, it will use the same settings that I used before. So I can click Gradient and then just click inside the range boiler and I'm ready to go. If, however, I had done something different, let's say I had done a regular hatch pattern, over here in the heat exchanger, let's put in a regular hatch pattern. I'll choose Hatch. I'll click in here and change that to a pattern. I need to increase the scale like that, and I'll say Close. Now, if I want to make another hatch pattern up here, I'll type H, enter, and this time I'd like to fill that with a gradient just like I had before, but I don't want to go through the process of configuring all of these steps. I can save time by clicking Match Properties and then click on an existing gradient or hatch to assume its properties. Then I can click over here and save a bit of time. Click Close Hatch Creation and it's done. Another thing that you should know when you're dealing with hatches and gradients is the draw order. Sometimes you'll make a gradient and it will cover up everything under it so that you can't see that stuff anymore. And that's not acceptable. We need to find a way to push it down. And the way to do that is to use the draw order command. DR, enter. Select this gradient, press enter, and send it to the back. Now I can see the borders of that panel. There's even a more efficient way to do that. There's a specialized command called hatch to back. Hatch to back. I see it right here. That will just send all the hatch patterns to the back of the draw order stack. That way, if you have any lines or text, they will automatically appear on top of those patterns. In the next video, we will edit existing hatch objects and watch as their boundaries automatically update. In this video, we will edit an existing hatch pattern. Go ahead and open the architectural sample file in the Chapter 8 folder and zoom in here. In this lower corner, we have a hatch pattern that really should be inside the wall that is spilling out over this cabinet area. Select the hatch pattern itself, and there doesn't seem to be any way to edit it. That's because this hatch pattern is no longer associated with its boundary. Go over here on the Boundaries panel and click Recreate. You can create a boundary as a region or a polyline. Let's make it as a polyline. And it says Reassociate Hatch with New Boundary. Yes, type Y, Enter. Then press Escape. Can you see the difference? There's a gray boundary surrounding all the hatch patterns, located right here. I can then use this boundaries grip to stretch it down like that. Press Escape. We can also use Stretch to reconfigure the walls. When we do that, the hatch pattern will automatically update. Use the Stretch command and make the kitchen wider. Do that by making a crossing window covering about half the kitchen. Enter. Specify an arbitrary base point and move it to the right and type in 2 feet. Enter. Now the kitchen is wider and the hatch pattern automatically updated. I'll select the hatch pattern and change it to solid. I'll also make it more transparent. It's on layer hatch, which is appropriate. Everything looks good. I'll click Close Hatch Editor. Now let's say this is a final design. I don't want to see the gray borders around all of my hatch patterns. They obscure the walls. So I can select this polyline and press the Delete key to get rid of it. I can go around and do that and get rid of these associated polylines. If we ever need to change the shape of the hatch pattern, we can follow that procedure where we recreate the boundaries, and then we have the editing capability of the polyline grips. But when we're done with them, we might as well erase them. The drawing looks a little cleaner now. So there you have it, ways that you can adjust the shape of your hatch patterns by recreating boundaries. We will create a text style in this video. Text styles control the appearance of text objects. Open the architectural sample file in the Chapter 9 folder, and then type Style. ST is enough for autocomplete. There are 2 text styles that ship by default, Standard and Annotative. I'll talk more about annotative objects in Chapter 15. Let's create a new text style by clicking this button. Let's give this style the name Technical. OK. The default font is Arial, and this looks fine in a word processor, but it's less appropriate in a technical drawing, where you want to have text appear with maximum clarity. I'm going to select a different font from this list. The fonts that you see here might be different on your computer because these are TrueType fonts that are installed in the operating system. And if you have Microsoft Office, it might install additional fonts. I'm going to scroll down, and as I do, notice that some of the icons are different. This has a compass and an A. This is an AutoCAD symbol. So this is a AutoCAD font. It's composed of lines that aren't filled, and these fonts go way back in AutoCAD's history to when pen plotters were popular. But they still are quite useful in creating simple fonts. So I'm going to scroll down all the way to Simplex, if I can find it here in this list. there it is, simplex.shx. It's a very simple font composed of single line representations. Avoid setting the height. You can set a height here, but then you're locked in, and all of the text that you make with this style has to be that height. I strongly recommend that you leave this at 0. That gives you flexibility later when you create text objects. They can be any size. I'd like to make this font a little narrower than usual. To do that, I'll set a width factor less than 1. I'll type 0.9. That will just squish the font horizontally a little bit. And this is helpful for getting text to fit in tight areas in technical drawings. Finally, click Apply and Close. We've created our first text style. In the next video, we'll start creating single-line text objects. In this video, we will create single-line text objects. Open the Architectural 2 sample file from the Chapter 9 folder. I've already set up a text style in this file. To verify this, type st-enter for style. Here we have the technical text style set as current, and you can see that listed right up here. This is important because when you create text objects, they automatically appear in the current text style. So it behooves you to set up the text style first. Now we can go ahead and create some text. Go to the annotation panel and open up this flyout menu and select single line. Specify a start point somewhere in this room just by clicking a point. Now the prompt says specify height. I could click another point to specify a distance from the first point clicked to the second point clicked, and that would be a height. Or I could type in a number here. Let's try 1 foot. Enter. Specify rotation angle of text. I'll go with a 0. It's the default, so all you have to do is hit enter. Now I'll type in some text. DEN. Enter. And that takes me to the next line. Then I'll type in bedroom. And I'll hit enter, enter to end the command. Now each of these objects is a separate text object. I can then move bedroom down here into this space. And I'll move this over. I actually think these two objects are too large, so I'd like to change their size after the fact, and that's no problem. I can select them both, and then go to Properties by typing PR, Enter. Here we can see two text objects are selected. Scroll down, locate the height parameter here, and let's make that a little smaller. Let's try 6 inches. Type 6, Enter. Oh, I think that's too small. Let's go with 9. 9, enter. The height that you use depends on the type of project you're working on. If you're drawing a mechanical part that's small, the text is going to have to be very small. If you're drawing a huge site plan, the text obviously has to be much larger. That's something we can get around with annotative styles, and that's a subject I'll cover in Chapter 15. But for now, let's just make text objects at the appropriate size for the drawing that we're working on. And that's something that takes a bit of experimentation to find. Notice that the width factor is automatically set to 0.9 because it inherits this information from the text style. Let's also change the justify parameter to middle. Press Escape to deselect. Close Properties panel, and then we'll just move these over. Now, an easy way to create new text objects is to copy existing ones and repurpose them. So I just copied that over. Then I'll double click on the text object to edit the information. That automatically uses the text edit command you can see down here, but I find it much easier just to double click on a text object and not worry about the command here. I'll just go ahead and type entry. Enter. Now let's say I want to create something like a room tag, which is a rectangle that has the room name inside of it. I can do that by drawing a rectangle around a text object, like so. But to really be accurate, it would be best to center the text precisely within the rectangle. I'm going to select this object, and you'll see that it has a grip right there in the middle. That grip appeared there because we changed the Justify option to middle. Let's draw a line across the diagonal of the rectangle, and then move the text object. I'd like to snap to that. Let me just move this out of the way for clarity. I'll move that object from a specific point. And to snap to that, I will hold down Shift and right click and choose Insert. This special snap mode allows you to snap to the insertion point of text or block objects. So now I've grabbed it precisely from that point, and I can snap it to the midpoint of this diagonal line. Then, select the diagonal and press Delete to get rid of it. So far, so good. Now let's see what happens when we copy this into the kitchen. I'll copy that over here and edit the text, kitchen. Now, it barely fits. I'd really like to ensure that whatever room name I type in this tag, in this symbol, it's going to be always fitting within the rectangle. So one way to do that is to use a special justification mode called fit. Let's try that by copying this rectangle down here. And we will also draw another diagonal line. Gives us a midpoint we can snap to. So let's go ahead and draw a new text object. And this time I'm going to choose the justification before I even start writing the text. Press the down arrow and choose Justify, and then Fit. It says specify first endpoint of text baseline. That would be right here. Second endpoint of text baseline. I don't want to click over here. I want to click some distance away from that to give the text some breathing room. So I'm going to hold down Shift, right click, and choose Nearest, and snap to a point that's about here on the line. The text height will be 9 inches, 9, enter, and the text will say kitchen. See how it gets smaller the more letters I type? That's the nature of fit justification, is it automatically makes the text fit in that space. So this is the kind of text I should use for a tag symbol. I'll press Enter, Enter to end that command, and then finally move the text up from its insertion point. In fact, this isn't going to work as well because the insertion point is in the lower left-hand corner. So I'm going to have to eyeball it in this case. I'm going to just estimate its position right about there. Now, I'll erase this previous incarnation of the tag symbol and move this up. So we have a nice design for this room tag. Now I can reuse it. I'll get rid of this text and I will copy this over here and then double click on the text and just type in bedroom, and you'll see that it fits in the box. So there you have it. A lot of different ways to create text objects to alter their justification, and I've shown you how to work with fit justification to make text fit in a box. In the next video, we'll take a look at multi-line text objects. MText objects have a new text frame property in AutoCAD 2016. To see how this works, let's create an MText object. Click two corner points to define the rectangle that the text will fit inside of. Type Manager's Office. Incidentally, another new feature in AutoCAD 2016 is this handle right here in the corner of the editor. You can drag that to resize while you're working, which is a new functionality. It used to be that you had to define the rectangle first and you were kind of stuck with the size of the editor. but now we can get the words to wrap while we're writing them. Click outside the text to end the command, and then click on the text object to select it, type PR, which is short for properties, and press enter. Scroll down and locate the text frame property right here. Change it from no to yes. We simply have a rectangle surrounding the text. This can be quite useful, and it can function as a room tag, for example, that identifies specific rooms within a building. We can resize this rectangle simply by using these two grips. Let's change the justification to middle center. If you drag this column height grip up too far and this one in, eventually you'll get this type of situation where the text splits into two columns. In this case, this is something we want to avoid. So to rectify that, we'll just make the column a little bit higher, and then they come back together. So by adjusting these two grips, we can get the rectangle to surround the text in question. I can also change the text by double-clicking, and it takes me back into this editor. I can then highlight the text and change what it says. Let's say coffee break room. And when I input that text, it split into two columns. I can drag right here to resize that rectangle, and then click outside and come back at a later time and resize the rectangle if I want using the grips. So it's a flexible system that simply reveals this rectangle, which has always been part of the mtext object. You've just never been able to see it before. Unfortunately, this property is not part of single line text. However, if we explode this mtext object, I'll type X for explode, enter. Select that and press enter. We now have single line text objects. And we have a polyline. However, you can't go the other way. You can't start with single line text and have it somehow generate the polyline for you. It only works in the way that I've shown you. The disadvantage of having single line text, of course, is if you decide later to change what it says. You no longer have word wrap functionality. So there you have it, everything you always wanted to know about the text frame property in AutoCAD 2016. In this video, we will edit an existing hatch pattern. Go ahead and open the architectural sample file in the Chapter 8 folder and zoom in here. In this lower corner, we have a hatch pattern that really should be inside the wall that is spilling out over this cabinet area. Select the hatch pattern itself, and there doesn't seem to be any way to edit it. That's because this hatch pattern is no longer associated with its boundary. Go over here on the Boundaries panel and click Recreate. You can create a boundary as a region or a polyline.